In this masterclass, we're going to know how to transform data using dbt, behind the scenes of dbt, and how it helps us in production grade projects. Everything a data engineer has to know from scratch all the way to advanced. And here's the best part. Well, I am going to explain the theoretical part of it. Alongside of that, we are going to work on practical labs so you can gain some hands-on experience. Without further ado, let's get started. Before getting started, I want to talk about how I structured this masterclass. I structured this in 6 separate phases, and each phase has a few different modules, and each module have the theoretical part and the practical part, which is a lab, and these labs will be demonstrated and the theoretical part will be explained vocally. So you'll get the practical knowledge and the theoretical knowledge alongside. And by the way, not every module or not every topic has lab. I only crafted these labs where it is necessary to demonstrate that particular topic. If it is not necessary, you will not have any lab for that part. And let me show you the document that I prepared. This one right here. So this is the document that I prepared, basically the study material, and I will be giving the link for this document to you so you can have it handy. Like I said, this masterclass is separated in 6 phases, and each phase have few modules, right? Yes. We will be beginning with the first phase, which is production setup and runtime, where we set up the whole infrastructure in this phase. In the second phase will be the core modeling engine, where we know about the main body of DBT, the core principles of it, and how to work with it. And then phase 3, we have testing and quality enforcement. We now in the prior phase, core modeling, we'll know about writing the crafting the DBT body, and in the next phase, we'll know about how we test the modules or the data source and stuff like that. So these are about testing and quality enforcement. And we have the next phase, which is documentation and observability. We basically talk about YAML specs, YAML documentation, and stuff like that. And the next phase is performance engineering. Talk about enhancing the performance, how to improve it, what the measures to improve it, and what not to do. And then we have environment and production strategy. That will be our last phase. And these are the phases. Well, now we know the structure that we are going to follow. But before stepping into the first module, I want to give you a basic idea of what DBT is, because we're not going to talk about that basic definition anywhere in these phases. Let me go here. Firstly, DBT stands for Data Build Tool. Okay, that's the definition of it. And now, the first question you have to ask is, what we actually do in data engineering? We transform the data, the raw data, into a business ready data. That's the main purpose of data engineering, right? And there are 2 approaches we can follow. One is ETL and the other one is ELT, extract, transform, load. ETL stands for extract, transform, load, and ELT stands for extract, load, transform. And when we talk about DBT, we can only use DBT in the second approach, which is ELT, and we cannot use it in ETL. And the main reason for it is, in order for us to use DBT to transform, to work on the data should be loaded somewhere before we transform the data. And by the way, DBT, the primary purpose of DBT is to transform the data. Okay, let me. That's good. Okay. The layer that we deal with DBT is transformation layer. We can use DBT for transformation layer to transform the data. And the primary requisite for using DBT is the data should be loaded somewhere. We cannot work on the data that is extracted directly using DBT. The data should be loaded somewhere. It can be a PostgreSQL, an SQL database, or Snowflake, or somewhere. It should be stored. And that is why DBT is not appropriate to use when we use the ETL approach. It only can be used in ELT approach. Extract, load, and then we use DBT for the transformation layer. We extract, we load, and we use DBT for transformation layer. And we basically use DBT by writing SQL queries for data transformation, and DBT actually orchestrates these transformations, the SQL query transformations that we write. It orchestrates in a DAG graph. DAG stands for direct acyclic graph, by the way. So it goes sequentially through the transformations that we orchestrate and transforms the data. That is how it goes. Yeah. On top of it, it has a lot of other advanced features that makes it a production grade tool to use. But besides that, this is the basic abstract of what it is. Now let's head to the first module. Now beginning with our first module, which belongs to the first phase. And the phase name is production setup and runtime, and the module name is production runtime architecture and containerized stack. Here in this module, we're going to see how we're going to install DBT core and the SQL database that we are going to work on with, and which will be Postgres SQL. Here, there are a lot of ways to install these two on your computer. You can just directly install them on your PC, or you can use virtual environment and install those tools there. But here we're going to use Docker to install these or create containers to manage these two tools, DBT core, one container for DBT core and the other one for Postgres database. And we are going to use that because that will isolate that environment completely from the machine itself, the host machine. Talking about installations, we can also use DBT Web. If you want to learn on DBT Web, you can also use that as well. They also offer free trial there. You can use free trial when you learn DBT. You can use that as well. But here, I've chosen this one because it runs on your PC or computer. And this is a conceptual architecture that we're going to follow when we install those applications in Docker. So this will be the host machine, which will be, this will be our host machine, which will be our computer. And then this will be the Docker network, completely isolated from the host machine. It runs in the containers. And there will be one container for DBT and the other one for Postgres. So that is what I said, Postgres container, and that will be our data warehouse that we're going to use. And we need a data warehouse because, like I said, DBT only works with the data that is already loaded, that is already saved somewhere. And the data will be saved in Postgres database. And so we need a Postgres container to be initialized, which works as a warehouse to store the data. And then we pull the data out of that Postgres database, and then we transform the data. That is how we do it. So we need one container for DBT core and one for Postgres running inside Docker. And there will be DBT project directory, a project directory, and then we mount the directory to the Docker containers. So it can have access to transfer data back and forth, So we basically do that as well. And then we will talk about Git repo. maintaining the Git repository and how dbt contributes managing your project in that Git repository. We'll talk about that as well. Well, Git is one of the major topic you have to learn about when we are working with dbt. So it is one of the major topic to know about. So that is how the setup will go. And talking about the execution lifecycle diagram, there it is. So developer writes the model.sql. That will be the first step. Basically us. We create the models. We write the SQL, the transformations in the models, and that will be model.sql. And then dbt container parses the project. It parses it, and then Jinja compiled and raw SQL. These terms, Jinja and raw SQL, you might be confused what it is talking about, but you will know as the topics or module passes. Okay, so it compiles what we actually wrote basically, and then DAG is constructed. Like I said, all the transformations that are done in dbt, we actually orchestrate those transformations. We don't just give the transformations and it randomly runs the transformations or runs the transformations parallel to each other. Instead, it creates a DAG. DAG basically stands for directed acyclic graph, which is basically goes like a flow chart, and it dbt, when it transforms the data, follows that flow chart. So it first executes this model, and when that is successfully executed, it goes to the descendants, basically the connected node, and it follows that graph when when we run the command dbt run. Well, these things might be confusing, but you will know about them later. But that is how it works. So the DAG, the graph is constructed and the SQL sent over Docker network. And then PostgRe, the compiled SQL. We write the code, the transformations in SQL, but it also contains the Jinja templates that we use. But the final compiled output will be the executable SQL that can be executed in the warehouse. If we, in our case, we're going to use Postgres warehouse, so that should be PostgreSQL that can be executed in that database. So the executable SQL will be next sent over the Docker network to PostgreSQL, because PostgreSQL is also will be running in one of the containers inside the Docker itself. And then it executes and materializes those. Like I said, we're going to talk about every one of these words: materialization and DAG, Jinja, everything. Then artifacts were written, basically the metadata of that uh, transformations. And then Git tracks the code changes. That is how the flow goes. Yeah, so the Docker isolates, Git governs. And then these are the few production principles we have to know about, which includes dbt is stateless. Dbt, it does not store data. Dbt does not store data. Dbt also, I have to say, dbt also does not execute the transformations. It only directs the codes that you write. So it compiles those codes or the queries, and then it directs those queries, the executable queries, to the warehouse, so it can be executed there. So basically dbt is like airflow, where we orchestrate the flow, but this is only focused on transformation part. It only transforms the data in an orchestrated way. That is it. Basically, orchestration means a planned way. We plan how the flow should go, and dbt executes. Dbt doesn't execute. Dbt makes those transformations executed in that flow. So it does not store any data. Data is stored in the warehouse. Like I said, it should be loaded somewhere, and then it writes artifacts only to the mounted volumes. We mount the volumes to the Docker container, like I said, and it writes those artifacts, basically the metadata, which includes the graph and a lot of other stuff we will talk about. So those metadata will be stored in the mounted volumes that we mount to the container. And PostgreSQL is the execution engine. This is where the actual transformations get executed. dbt just routes them to that PostgreSQL, and PostgreSQL is where the engine is where execution happens. dbt sends SQL. PostgreSQL executes it. Indexes must be managed manually. Search path must be controlled. Containers guarantee determinism, no host Python, no local Postgre installs, no works on my machine problems. So the main reason we are using Docker is because we want to isolate it completely from the host machine. Let's say you're working on dbt, okay, and you run your transformations, everything in your machine, and it works fine, and you want to replicate the same thing in a different machine. If you install dbt core locally, it might not work. The transformations might not work the same way as they worked on your machine, and that is the problem Docker fixes, because Docker isolates everything from the host machine. Everything you can run in that container, in the Docker container, can be run in the same way in a different machine as well. So you don't get this kind of problems and say it works on my machine but it won't work on your machine. So you don't get any of those problems. And Git is mandatory when you work with dbt. That is because without Git you don't have any rollbacks. You cannot go back in time to get those files. And then CI enforcement, we'll talk about CI enforcement, continuous integration later, and then version discipline and review process. These are the principles you have to know before we get into the core concepts. Now, here's the main part. We step into the lab 1, which will be building the setup in Docker. First, we open PowerShell and create a folder which will be our project root repository using mkdir. Mkdir stands for make directory. And everything we are going to write, the commands that we're going to execute will be executed from the PowerShell, by the way. But the codes that we are going to write will be done using VS Code, Visual Studio Code, code editor, but the commands will be run from the PowerShell. If you haven't worked with the CLI before at all, I'm going to give you a brief introduction of how this works. This is basically you working with your computer, but without using the UI. That's it. And we have to do this to habituate, to adapt to this CLI instead of using the UI, because in production grade projects, you don't use UI because you rent out the virtual machines from a cloud provider, right? And those virtual machines doesn't comes with a UI install. It doesn't have Windows in that machine. So you have to in order to communicate to that machine, the only way is to write commands. So you use CLI, command line interface, to communicate to that machine. That is why I'm using CLI here as well. And the basic command include a few, which also includes this one, mkdir. Mkdir stands for make directory. We are creating a directory, basically a folder. And name the folder as dbt core production. Run it. After we run it, this should create a folder in that location, which is the C drive users and the username. DBT core production, and right now it is empty because we just created the root repository folder. That's it. Now we use cd and cd stands for change directory. Now whatever we write here, we type whatever the command that we type in or run here will be executed in this location, yes. So when we created this folder using this command, it got created at this location, C drive users and the username. Now when we do cd in that particular folder, the location that we run the commands will be changed to that location, like that. So whatever we run here will be reflected to this location instead. Now we do that. Now we create a file, docker compose.yml, and copy paste this code. This code is nothing but us creating the containers in Docker. And by the way, to install Docker, it is so simple. It is a free tool that you can use. You don't have to pay anything. You can just go to any web browser and search for Docker Desktop. Click on the first link. Click on Docker Desktop, download Docker Desktop, and choose your specification and download and install with the default settings. You don't have to change any settings while installation. You can just install with the default ones. Well, I'm going to provide the link for this page directly from the description. I mean, in the description, you can click on that instead. After installing Docker, open it. And this is the home page you will be landing on. You can just skip the sign in or sign up phase. This will be the home page that you will be landing on, and all the containers that we will create can be listed here. Right now I don't have any containers running, so there are none here. Let's minimize that. Now another tool we are going to use is Visual Studio Code Editor. This is just a code editor. It makes writing codes or managing them a lot easier. Okay. Now this is also a free tool you can install, and I'm going to provide the link for this one as well in the description directly. And this is the home page. Wait. It somehow got connected to the folder that I created just now. That is because I already worked with it. But when you open it for the first time, you can just click on open folder and navigate to the folder that we just created, the project repository, which is DBT core production. Select that folder, and that is how you list the folder here. And you can create files, delete them, and do whatever you want from here itself. Now we're going to create our first file, which is dbt compose, sorry, docker compose.yml. First file, run it. Copy this code, paste it here. Since we copied this code from Word document, you will find a lot of empty spaces that gets ingested to the pasted text here, because we copied that from the file, the Word document, and the format is quite different. So what I'm going to do is I will also give you these files, the docker compose.yml and also the Docker file, through a GitHub Git repository link from the description as well. You can just download these files and not copy paste them from the Word document, because you don't want to face this issue. Now what I'm going to do is I'm going to take this out because it has a lot of empty spaces, and get this from the file that I already have with me. Okay, I'm going to copy paste that. So this is how it should look without any extra new lines. So basically what we're doing here is we're creating two containers. Okay, one container for Postgres and the other one for dbt core. Talking about the first container, which is Postgres, the image we're going to use Postgres, obviously, and container's name dbt Postgres. The name in the container and restart is always an environment. We are defining the environment variables. Basically, we are saying Postgres user as dbt user. So this is the username, and Postgres password as dbt password. Basically the Postgres, the database password, and the database name Postgres DB as dbt warehouse. This will be our database name. You can just configure that as you like. And by the way, this is not recommended in when you want to learn creating a container in a production grade. You should not expose these credentials right away in the Docker Compose file. You have to use environment variables, but we are just learning here. So I'm just leaving like that, just like that. So this is the username we have to use to connect. This is the password, and this is the warehouse that we created, that it will create in that database. I mean the database name basically. And this is the port 5432. This is the listener ports. And the volumes includes Postgres data, var library Postgres SQL data. We're mounting the volumes and then dbt network as network. And here, this container is for dbt core. Build container name dbt core, and we mount the volumes, say dbt project, and okay, dbt project and dbt project slash .dbt to these two locations. I mean, we're just mounting to that container. So this location will be from wherever we are running this Docker, and that will be our root repository dbt core production, and this location will be dbt core production slash dbt project. That will be the location that this volume got mounted to, and depends on Postgres. So it depends on Postgres, the dbt core, and the network has dbt network, and that's it. Well, this image for this container, we got the image that is already predefined on the internet, but for this one we are going to build an image for dbt core, our own image, and we haven't built it yet. But to build an image, we are going to create a new file, which will be step 3, and the file name should be docker file, new file, docker file. And here we define the image, we create the image using this code. Like I said again, I'm not going to copy this because it has a lot of empty lines. I'm going to copy from this. and then paste it here. Now what we're doing here is we are using Python 3.11 version, and then we are installing the essentials we need first before we install the dbt core and the connector. And then here we run this command which installs dbt core with this version 1.11.6, and that is the latest version that is more stable. So we're going to use that version, dbt core 1.11.6, and this is a Postgres connector we're going to install along with the dbt core. And by the way, if you want to use Snowflake instead of Postgres as your database, you have to install the Snowflake connector instead of the Postgres connector here. So instead of using Postgres here, you say Snowflake, and that will install the dbt to Snowflake connector, so dbt can connect to that database. But here we use Postgres, so we are installing the dbt Postgres connector. And this is how we defined this image. And from that, referring to that image, we are creating a container for that image to run that image. Now let's save this. The next step is docker compose up and -d build. Now after saving those files, under our root repository, our project repository, dbt core production, we open PowerShell, or you can do that from here itself, from Docker desktop itself, instead using the terminal from here, or you can use PowerShell. That's fine. Either way it works. You just need a CLI. So from here, we run docker compose up. Docker compose up turns up the containers that we just defined in the docker compose YML file, and docker compose down command will shut down those containers. So we use up to turn the containers up and down to turn the containers down. We just replace this particular word here to do those stuff. Okay, and we use this flag -d, and that stands for detach. If we don't use that flag when we turn the containers up in Docker, this CLI will keep showing the logs of those containers, and if you don't want to see those logs here, you can just add this flag at the end, -d, and then what else? We use build at the end. Let me close this. Okay, we need this. Okay, and we need build at the end. Build. And we have to run -build because we just defined the image, right? We defined our custom image. So we have to run build in order to install the required dependencies and create the image and then turn the containers up. So we need that. Run it. This is going to take a while because it needs to install all the dependencies, all the requirements, and then turn the containers up. And after everything is done, you'll see something like this. It says the containers got created and started. Now, if you open Docker desktop, you can see two containers. One is running and the other one is stopped. Well, the dbt Postgres will be running and dbt core will be stopped because it shouldn't be running all the time. It only runs when you execute dbt run or any of the actions. That is when it turns up and runs that command and it shuts off again. It won't be running continuously. It doesn't make sense. So but the Postgres, the warehouse will be running continuously. And then to confirm the warehouse is actually running, what we can do is you can run that command. By that, you are accessing dbt Postgres container inside the Docker. So because it is running inside a Docker container, we have to start the command with docker execute, and then this is a container that we want to access, dbt Postgres. That's the container name, and PSQL, we use PSQL, and this is the user, dbt user, because we define the user as dbt user, and this is the warehouse we want to connect. That is how we connect to that warehouse, and whatever queries we run here are going to be executed in that warehouse. Right away, we can just right away write those SQL queries here. Now, for example, I'm going to write \l. This will list all the warehouses. Okay, this will list everything that is in the database, and the access privileges and everything. So this this is to make sure everything is going fine and everything is working. You should see something like this. It lists everything that is in there. And to quit this connection to the warehouse, you have to type in / and q. Enter. That's it. Okay, now we're done with that. Well, we're done with turning to know. Now we know how to turn the containers up. But like I said, we can, after you're done with those containers, after you're done working with those containers, if you want to shut them down again, you can just do that using Docker desktop right here, or else, like I said, instead of doing that, you can say Docker compose down, and you can use V. V stands for verbose. It clears out all the cache data and everything stuff. So you can use that command, enter. This will turn down the containers. You don't see them again. And that's it. That's it with the installation. Now let's head to the next module where we see how to, initialize the stuff after the installation of dbt core. Now, beginning with our module 2, which is runtime configuration, environment isolation, and connectivity validation. This is where we initialize dbt before we actually see how we create or write the models and run them. We initialize dbt first, and we have a configuration diagram for the levels of it, the configuration. Firstly, we have dbt project. This is the whole project level configuration that we can do to configure where the which profiles to use when we run dbt, and where the file locations are defined, and where even the materialization of the models, everything can be configured in the project level in this file, dbtproject.yml. We will see how to configure it as well in this same module. And then we can point to a profile that we created from this level itself. So first, when we run dbt, this is where it looks. This is where the dbt looks for the configurations that file, the dbt project.yml is where it looks. And after that, in this project.yml, it will define the profile, the name of the profile configuration, and through that name of the profile configuration, it navigates to that profile, which will be this one. We are going to create a profile name with this one, and then it routes to profile.yml, profiles.yml, where we can configure profiles inside that file, and select a target. We are going to create basically two environments. So, which means we are also going to create two profiles, one for the production and one for the development. And we have Postgres adapter initialization, and then connection pool creation and schema routing. Not just we create two profiles, one for development and one for production, we are also going to use two separate schemas for both of them to see how dbt actually works in real world. Instead of just creating one profile and one schema, we're going to use two isolated profiles. Now, beginning with configuring the profiles first. Like I said, we're going to create two profiles, developer and the production environment. Well, profiles.yml controls host resolution, credentials, and the database name, schema routing. It routes to the schema, to the appropriate schema for that environment, and then thread concurrency, target switching. So dbt reads profile from dbt project.yml. Okay, so like I said, it reads the profile name from that dbt project.yml, and then load matching profile from profiles.yml. We have a list of profiles in that profiles.yml, and the matching profile that is configured in dbt project will be selected, will be loaded. Then initialize adapter, establish connection, and through that profile, it establishes the connection. Now, for this lab, we're going to create a few things. First, we're going to create a directory named dbt project. It already exists. Oh, it is already created because we already mounted these volumes to the container when we turn the containers up. It automatically creates these volumes for us, so we don't have to manually create them because we already defined them here. If they exist, it just leaves them. If the volumes doesn't exist, Docker creates them manually, automatically. And that is why we have these folders created already. So we have dbt project slash dbt already created. And inside .dbt, we are going to create profiles.yml. To do that, right click here, new file. And in this folder, we can define multiple profiles, and according to whatever we define in the project.yml, it chooses that particular profile from this file. And for the contents of this file, I'm going to say dbt production profile. This will be the identifier that we can use in the project.yml. Target. Set dev. This will be the default target for that profile. Outputs. Here, one for developer. So I'm going to call it dev. And this will be, like I said, because we define target as dev, this will be the default one. But if you want to change the profile from developer to development to production, you can just switch this to prod, PROD, prod production, or else you can just switch it when you run the commands itself. Postgres. Host. Postgres. User will be dbt user because we haven't configured it any of that. I mean, we haven't configured any different username. I just left the user as dbt user and password as dbt password. So I'm going to use the same thing here as credentials. And the port will be the listener port, which is 5432. 5432. DB name will be the database name, which is dbt warehouse, because we configured that database already, dbt warehouse. dbt warehouse, and for the schema, like I said, we're going to separate the storage space that is allocated to development environment and the production environment, so they are isolated from each other. So we define one schema for development, which is dev schema, and the other and another schema for production, which will be prod schema. When we work on a project in real world, like production grade project, we usually isolate these storage spaces or the warehouses by database level, not just the schema level. We create a separate database for production and a separate database for development. But here, we're just learning stuff, so we don't have to create a new database for that. Instead, we can just isolate the schemas and that will do as well. So I just isolated schemas for development and production. And threads, let's say 4. And depending on the threads you define here, it defines how many connections can be allocated to that particular database at the same time. So here I said 4. So 4 connections can be deployed to that database at the same time. So it depends on threads, how many parallel connections can be deployed to that particular database. Here I said 4. For this profile, now I'm going to create one for production. And use the same stuff here. But I have to change this one because we are isolating the schemas. We say prod schema and threads. Let's say usually production environment has more threads than development environment. So I say 8 here. Now the profiles.yml is ready. Like I said, if you're working with in the development environment, the target should be dev here. Or else if you want to work in the production environment, you just switch the target to prod, production. Or else you can configure that in the command itself when you run it. You can just configure the target as production, and then that will switch automatically. Or else you can just edit this profiles.yml file. Now we're done with that. Well, that's it for the first lab, I think. Yep. Like I said, in real production, we use separate databases or clusters. We don't even isolate them in the schema level, we isolate them in database level itself. Separate credentials too. We use the same credentials here. Yes, we use the same credentials, which is dbt user, the default ones, but we use separate credentials as well in the real world. Now the part 2 is dbt project initialization. We are going to create the project. We are going to configure the project.dbt project.yml file here. And this is the conceptual diagram. We already created this. We have that already, dbt project. Now when we initialize dbt project inside here, it creates another folder, dbt project, which has dbt project.yml, where we can configure the project level configurations, and then we have one folder for models where we can where we can write the models for the transformation, and then macros. These are all the folders, and they all have their own value for when it comes to the transformation, and we will know for about every single one of them in the upcoming modules. But now there is the whole structure. It has a folder named macros, seeds, snapshots, tests, and target. Target will not be created when you initialize, but target will be created when you compile or run anything. And this one, finally, we already created this, which is .dbt profiles. And it says every .sql file inside models becomes a becomes a DAG node. Like I said, all the models, this dbt orchestrates the transformations, but it doesn't run anything. And when I say orchestrate, it creates a DAG file with multiple nodes, and nodes depends on the .sql files that are inside the models. Now, heading to the next lab, which is the initialization of dbt. Now, for initialization, we open PowerShell. And there is one thing that I have to say. If we install this dbt core directly into our machine, we just run a small command, which is dbt init. That's it, to initialize dbt. But because this dbt core that we installed is running inside a container in the Docker, this command line is going to be quite lengthier than the usual one, the regular one. But don't you worry, you face a difficulty when you write it for the first time, but you just copy paste it in a notepad and then switch the commands, the actual part, and it is actually the same command for every single what to say execution command. When I say that, what I mean is, so the main part is, because dbt core is running inside Docker, our command should start like this: Docker compose run and here. So this part is common for everything that you run. Every dbt command that you want to run, it has to be enclosed with this part at the front, and we say the actual command, which is dbt init, and say okay. Now, basically, by this command, what we are telling a CLI is, because our container is running inside Docker, we say docker compose run. So run this inside Docker, and the command is this dbt init, but it doesn't know where to run. It just runs at the root, but we don't want that command to run at the root of that repository, but this command should be run in the project directory, which is dbt underscore project. Basically this one. So it runs under here. So when we run dbt init under this folder, it creates another folder named dbt project inside it. Okay. Run it. Now this command will initialize. Oh, my bad. Something went wrong, I think. Okay, so there is one single mistake that I've done. I define, no. So the command is correct, but the part that I shouldn't include is this one. And run it. Now this will initialize dbt, but that part should be included from the rest of the commands that we're going to run after initialization. And I will talk about it, okay? So here, now for the initialization, it asks for the details like the database we like to use. Right now it only has one option, which is Postgres, because remember when we installed the requirements, the dependencies, when we created the image, we only defined Postgres connector, Postgres to dbt connector, and not any other connectors. So it only has one connector, which is Postgres to dbt, and that's why we only have one option here. And it asks for the host name and stuff like that, but we don't have to configure that. If you want to configure it, we can, but we're going to skip that because we are going to configure that manually. So I just skip that using Control plus C. But it is initialized. It is initialized. So when you click on the drop down here under the dbt underscore project, we can actually see a project repository created, dbt underscore project, and logs, of course. When you click on the drop down, you can see all the files that are listed, and uh, it has macros, models, analysis, seeds, snapshots, tests, .git ignored, dbtproject.yml. We talked about that file, dbtproject.yml. That's the project level configurations that we can use. There you go. So this is the default project configuration, but we have to configure it according to our need, which includes switching this profile. By default, it goes to dbt project profile, but our profile is something. Let me close these two. We don't need them. So our project profile is something named like this. So it is named like this, not something. It is named as dbt underscore production underscore profile. This is the profile that should be defined under dbt underscore project.yml. So we replace this with our profile that we defined and save that. After that, clean targets, target dbt packages. These basically when we run dbt, when we want to clean everything, the cache data, so these are the locations dbt will clean up: target and dbt packages. We don't need to touch anything, but we have to, by default, when we initialized, dbt comes with example models already created. We don't need them, so we're going to delete the whole example folder itself. Right click, delete. So the whole example models folder is deleted. Now switch this. Oh. Now take this line out because we don't have a folder named example. Take that line out. Now by this particular part, we are saying every model that we create, every entity that we create through the models, will be materialized as a view and not table. You know, SQL tables, SQL views, and stuff. So we are going to, whatever the transformations that we do, they will be saved as a view in the database and not the table, because we defined it in the project level as the materialize, and we materialized it as view. We can also materialize that. Uh, you can also use folder level materialization, and yeah, we can do that as well. But for now, this is project level materialization. So any model that is executed under this project will be materialized as a view in the database. Here is the name, the project name, and then profile. We already edited that. And model path, we can configure the model paths as well, but by default these are the model paths. Nobody actually changed them, but if you want to change to a different path, you can. This is the analytics path, test path, seed path, macros path, snapshot path. But you might be wondering, there is no path for targets defined, right? Because we already talked about the structure. It also includes target. It has everything, but it doesn't have target defined. Well, by default, it already connected to the folder named target, but you can also do this and say target. Or you can switch this to a different path name as well. That's fine. Depends on you, but by default, this is already taken. We don't need to define it, but you know, just to show you, we can. Now we configured everything that we need for now for this, but later we're going to switch these materialization to see the folder level materialization and the folder level materialization and the rest of the stuff in the upcoming modules. But for now, we're okay with this. Save that. These are all, like I said, these are all just comments. They're not included in the actual code. We can just take them out. We don't need them. Oh, this comment, by the way, like I said. So these are the things that will be cleaned when we run dbt clean command. That is what this command says. Take that out. What just happened? Now, after cleaning all that stuff, this is the actual dbt project.yml file should look like. These are all project level configurations again. Okay, we're done with that. And we already talked about Git plays a major role when we work with dbt. And when we initialized, by default, it also comes with .gitignore. If you don't know what .gitignore is, well, when we push something into Git, we don't want all the files or all the folders to be pushed into the repository. We want to hide something from the Git. So if we want to hide something or ignore those files or folders to be pushed into Git, we can mention them in this file named .gitignore, and here are the files. We ignore target by default. It comes with ignoring target, any files in the target folder and any files in the dbt packages folder, and logs as well. So we don't want anything in the logs, target, or dbt packages to be saved in Git, because target has, like I said, target has everything that is the metadata from our dbt run or dbt compile. So that is just about metadata. We don't want that to be saved. And these are basic README that we can use in GitHub to read, uh, to save something that is more readable, basically. Okay, I think that's it with this lab. Now let's head back to the document. Now the part 3, the third part is end-to-end connectivity validation. Now we validate what we just initialized. To validate them, we run dbt debug. Like I said, the command that we used when we initialized dbt is this. Let me zoom it a little bit. So this is the command that we used, dbt compose run and hyphen hyphen rm dbt init dbt underscore project. But from the commands that we are going to run after initialization should include minus minus project directory to define the project directory to define where to run that command. And this part at the front and this part at the end should be common, should be commonly included for every command that you want to run in dbt. But this part enclosed by these additions is the main dbt command. Here dbt debug is the main command. If you, like I said, if you installed dbt right away into your computer, you can just run dbt debug and not these extra things needed. But because dbt is running in Docker, we need those additions to at both the ends to run that command. Basically to direct that command to run in that particular location. So what I actually do is I copy paste this somewhere in the notebook where it is handy. So when we want to run any dbt command, we can just copy paste this command, or we can just replace this part. Let's say if I want to run dbt debug instead of dbt run, I'm gonna replace this and say dbt debug. That's it, and copy paste this lines so that we don't type the whole command every single time we want to run a dbt command. Like that, I copy that, close this, run it run it here. Now we debug, and here it debugs all the setup that we just initialized, and it checks for and it validates the files that we created with profiles.yml, dbtproject.yml, and see if that is actually good or valid. It says okay, found valid. If something went wrong, you'll see something in red color saying the error, but here we only see green, so everything is checked and everything is passed. So it checked profiles.yml, dbtproject.yml, and it checks for the connectors and everything. And also it checks the connection between Postgres and dbt. So here it did check the connection with the Postgres at the port, and it is successful. But here we have to see, because by default we define the target as developer or development environment, this connection is only valid because it checked with the development environment. Because here, you see that? So it is checking the schema, the connection with the development schema or developer database, basically. But we don't know, we haven't debugged the connection with the production environment yet. To do that, we just switch the target. Like I said, we can switch it in the file itself here, right here, and switch the target from dev to prod. Or else, if you don't want to switch the default from dev, what you can do is you can just slightly modify the command that you run to target the production instead. To do that, what we have to do is we can use the same command that we used, docker compose run dbt debug in the project directory, but here we're going to add something, say target prod. Now the target is switched to prod with that command. It will not permanently switch it, it only switches for that particular command. That's it. So for this command, the target will be production and not development. Copy that, run it. Now all the connections are successful again. Here the schema is prod schema, so it actually the target is actually production now, and it checked all the connections in the production environment too, and they're also successful. That is how we debug. So if anything goes wrong here for you, if you see anything red saying the error, you have to fix it before we proceed, or else you will face issues later. So fix them first and then proceed. Usually don't get it because I will give every code to you as well. So you basically are replicating my setup on your computer. So you shouldn't usually get any errors unless you did any mistake. So that's the lab 3, just debugging, and the lab 4 will be actually running a small model and seeing if that actually works. The setup is actually working. For that, I'm going to create a small SQL model, just one single line, model with one single line of SQL query. To create a model, like I said, let's create one under macros. Select one as connection. We basically has to follow the best practices. So I'm going to use the capitals. Select one as connection test. That's it. This will create a table, or sorry, this will create a view because we materialized everything under the project level as view. So this will create a view with one column, which is connection test, and that one column only has one row, which is 1. Save it. And by the way, I don't know if I mentioned this. When we run dbt run, whatever you save the file, wherever the whatever you execute, it depends on where you save that file at. If you, sorry, so like here, I did a mistake here. I saved this test connection.sql under macros and not models. If I do that, I will definitely face an error because this is a model and it is saved under macros. So you have to be careful where you save that particular file. So only actual macros file should be under macros and the model should be under models and not macros. So it is strict with the structure. dbt is very strict with the structure, so you shouldn't do any mistakes like that. So now I cut that from macros location and pasted it in the models. Now this will be considered as model and not macros. And same applies to all the folders. dbt highly depends on the structure and where you save the file set. So the way of it compiling that file depends on the location of it. Okay, now I saved it under models. Save it. Now I execute dbt run. And by the way, I don't need this because we're going to run it in development environment. So instead of dbt debug, we say dbt run. Like I said, we don't change any of this. We don't need to change any of this. We just change this core part, the core command, which is the dbt command. We said dbt run here. Now copy the whole command, run it. Now that is executed. It says when we run a command, this is how it looks like. So there is the line from here. It shows the time, level, message, and where it actually executed and all that stuff. And then here, running with the dbt version, and it also shows the adapter, the PostgreSQL, the connector version basically, and then it shows the number of models as 1 and number of macros. And by the way, well, we haven't created any macros, right? But by default, we'll get a few macros that are already created by default when we initialize dbt. So this is the count of those default macros that got created. But model is only one that we created. Concurrency, 4 threads, and the target is development because that is the default target. 1 of 1, start SQL view model, dev schema, test connection, and created SQL view model, dev schema dot test connection. And this is the view name that is saved in the warehouse. Now it says create view, completed successfully. So we haven't got any errors. Now let's validate this view is actually created in the warehouse. To validate it, the command we have to run is we already typed that in, right? Yeah. So we use the same one. We use this line again to connect to the warehouse. Now here we query the view that we created. So to query the view, I'm going to say select all from dev schema. Basically, I'm going to copy paste this part. Dev schema, and the view name is test underscore connection. And semicolon at the end to end the transaction. Run it. There you go. Now it prints the view with only one column, which we defined as connection underscore test, and with only one row, which is 1. That's it. And yeah, to exit from the warehouse, the connection, we say \q to quit. And that's it with this lab. And with that, we're done with module 2, which is runtime configurations, environmental isolation, and connectivity validation. We did all of them. Now let's head to the next module. And for our next module, we have Git Foundation for dbt. And this module is not going to be lengthier because this is just about how we initialize Git in DBT and how we work with it. Basically, for the people who don't know what Git is nothing but Git is a tool that helps people to manage their project, all the files and everything related to that project. So you can save them online. And along with that, on top of that, there are a lot of features that Git offers to you, like version control and branch isolation and stuff like that. And there are a lot more to deal about, deal with when you work on Git. But I cannot explain every single one of them because Git alone should be a separate masterclass. So, yeah, I will launch a masterclass on GitHub or Git as well. But for now, that's just the foundation that I'm going to give you guys. Okay. And yes, for DBT projects, obviously, we need Git is mandatory to have. And here it is. Git governs model evaluation, change tracking, peer review, CI enforcement, rollback capability. Rollback is nothing but what I talked about, version control. It can roll back to the versions, older versions or older states of that project. And CI is something about production and development environments. Well, we do save everything related to our project in Git. That's true. But we save that in the main branch. Main branch is the main one, like it says, it's a main branch. But we don't. If you want to develop a new thing or if you want to modify that project, we don't directly work on the main branch in Git. We work on an isolated branch, a separate one, and then after you confirm the changes are good to go to the production, then you as a developer do a pull request to implement or integrate those changes to the main branch, and that is what CI is. CI stands for continuous integration. So you say that so this branch is good to go, good to integrate with the main one, and then when we enforce CI, it comes with a few tests before the branch that you worked on in the development environment gets merged into the production environment. So it goes on the new changes goes through a few tests before it gets integrated to the production to see if it is actually valid change, if there are actually valid changes, or what to say, if the changes doesn't have any errors in them. Okay, that's how Git works. Okay, we have that. And also, it is easy to reproduce the same project somewhere else when we have Git repository. I mean, the project initialized in Git. The conceptual diagram, Git layer tracks file system, branch isolation, like I said, production and development, and then commit history, rollback capability. These are all Git factors. If you know about Git already, you would understand these things, but if you don't, you might uh, see these things pretty new. But yeah, like I said, Git alone needs a separate masterclass. And the DBT layer is responsible for model lineage, DAG execution, compilation, materialization. Git controls the code, DBT controls the data transformations, basically. And the lab, we don't have much of a lab in this module. Like I said, it is so simple. We run this command through in our project repository to initialize Git in it. For any new project, we should initialize Git in that project first, and from that we customize .gitignore. Like I said, when we ran dbt init, it comes with .git ignore already. So what this does is it ignores all the folders or files that we mention in that particular file, the .ignore file, the .git ignore file. And here we usually add target, which it already comes with it, right? Target, dbt packages, logs as well, and then PyCatch, the Python catch, PYC, environment variables. We haven't used them, but in a real project, there is a high chance of us using environment variables. Oh, sorry. And then, yeah, any file or folder the Git has to ignore and not save it in a Git repository. Should be included here. Then we run git add dot. Dot is nothing but adding all the changes, and once all the new changes that are done to the repository, we commit those changes with a message. That is how the usual flow goes. But in actual production, like I said, we isolate the branch from production and create a separate branch for development. And after the changes in the separate isolated branch is, if you believe that branch is ready to ready to integrate with the production one, then we trigger a pull request, and then it goes through that dbt the tests, and if the tests pass, then it is merged to the main branch. This is how it goes. So we switch the branch using this command, git checkout feature add staging layer. So this is the branch name. That is a branch name. We create a new branch and we add all the changes. We do our modifications to that branch because that is isolated from the main one, and then those changes will be added and committed in that branch. And when we switch back to the main using git checkout main branch, we merge those changes, which is nothing but integrating those changes to the main one. Okay. See that? Okay. Now, a future CI pipeline will pull repository after a developer triggers a pull request, pull repository in the CI process, build container, run dbt compile, run dbt test. It has a set of stuff configured by the user. We configure those tests as well in the CI layer. When everything goes fine, it gets integrated. If something fails, fail pipeline if tests fail. So if any of the tests fail, the pipeline will be failed. It is not integrated to the main one. That is how Git or GitHub works. That's it with the model. I just want to give you a brief introduction of what Git is if you don't know what it is. But like I said, I will create a whole GitHub masterclass in future in a few weeks. But if I do that, I will try to attach attach that link in the description so you can refer to that. Okay, let's head to the next module. Now heading to our next module, which is module 4, which belongs to phase 2. Yes, we're done with the first phase, creating the infrastructure. Now we are heading to creating the models and working with it. The phase 2 is core modeling engine, and module 4, which is dbt project structure compilation model. Here we learn about how the dbt project is structured and how each of those structural elements work. We talked about this already. In dbt, directories are not cosmetic. They're not just for the visuals. They are actually semantic, which means it depends the way DBT considers the or work with the file depends on where you place the file. So where you place a file determines whether it becomes a DAG node or whether it compiles, whether it materializes, how configuration is inherited, how lineage is constructed. So everything is dependent on where you place the file. And this is the conceptual diagram. We have a conceptual diagram here. It says file system. It's nothing but the file, the structure, the basic skeleton of the project file system, which has modules, seeds, analysis, macros, all those folders. And then DBT parsers and parser and compiler, and DAG construction, which creates a graph, and materialized relationships, tables or views. This is the flow it goes. The file system is the input language. The DAG is the logical graph. And warehouse is the execution output. Now, first talking about models, about this folder, which is this one. We already talked about it because we already tested it using test_connection.sql. We know more about it now. So models contains .sql files, which are nothing but the transformations that we do. Each file becomes a DAG node. So whatever file that is in the models, all the transformation becomes the nodes of the DAG file. No, we shouldn't call DAG as a file. So all the .sql files that are in the models becomes a node in the DAG. Like I said, DAG is a graph, direct acyclic graph. It's nothing but a flow chart. And each node represents a .sql file. Each node compiles into SQL. And each node that we write, you might wonder, well, we do write SQL in these files, right? But no, we don't just write SQL in these files. We also include Jinja. We will talk about it later. We will also include a few other formats that we can use in DBT. So this, whatever we write here in the models, will not be fully SQL. It also includes a lot of stuff. Like I said, Jinja, and we also refer to the other tables in the DBT itself using the code. So we don't purely write SQL here. We include a few other stuff. So it needs to be compiled into a pure executable SQL, then will be sent to the warehouse where it can execute it. Because if the SQL that is sent to the warehouse is not pure, it cannot execute it, because warehouses are built to only execute pure SQL that is executable, right? So yes, each node compiles into SQL. Each node will be compiled into SQL first, and then each node materializes unless disabled. Each node materializes. Each node, whatever the transformation that we do, it will be materialized. Right now, we materialized everything under DBT project as views in DBT project YML here. We define the materialization as view. So everything that we write in those nodes will be materialized as a view. And then DBT recursively scans this directory. So it scans this directory recursively to check if there is any valid .sql files, the new ones. Says if a macro file is mistakenly placed here, DBT treats as an executable model, and because it is not an executable model, it will not execute. So we have to be careful where we place those files. So the file placement is so important in DBT. Now let's head to the first lab in this module, which is node discovery experiment. Okay, let's do that. Set to VS Code and create a new model. Let me close these files. Create a new model, new file, and name it testmodel.sql and write a simple SQL code. Now save this. Okay. I forgot to mention, before in module 2, we talked about the structure of our repository, right? And we said target, the folder target will not be created unless we run dbt run or dbt compile, right? So this folder will not be existed if we haven't run any of those commands. But because we ran dbt run in module 2 lab, this target folder got created. It has all the metadata in it. Now we have this. Because this lab is about what? Node discovery. We are just going to see how the node is discovered by dbt. Okay. Now I'm going to run dbt compile. I'm not going to run dbt run here. I'm just going to run dbt compile. What this does is it doesn't run any of the transformations. It only compiles the transformation or the .sql files that we write and stops. It don't run them. So when I copy this and run it, so it shows two models, which means our new model got discovered and added to that, to the modules. So I mean to the models. So here it says two models and it is compiled. If you take a look at it, it haven't run anything. It just compiled. And that is why we use dbt compile. We haven't run anything. After compilation, if we go to target and extend the drop down that says compiled, you can actually see all the models that are just compiled, which includes test connection. This model that we created, we actually ran dbt run after we creating that, which means it compiles as and run. It also runs as well. So it compiles and runs. So this is here under the compiled, and we have test model which we just created, and that just got discovered, and it is also compiled. This is a file that is compiled. What compilation actually means is, like I said, whatever we write in that models is not fully SQL. It also includes a lot of stuff. So before sending those SQL queries directly to the warehouse, dbt compiles those queries into the executable SQL that is understandable for the database. And that is what it does. And because we just write a simple SQL query, which is select one as test underscore column, which is a simple SQL and nothing complex, even the compiled version is the same. But I will show you the difference between the compiled and the actual model that we write in the next upcoming labs, where we use a quite complex logics, which also includes Jinja and Jinja templating and stuff like that. Then you'll actually see what the difference between the compiled and the actual model that we write. Now, because we just compile, we just ran dbt compile and not dbt run, you can only find this model, that the new one, under compiled and not run. You see that? So we only run dbt compile after creating this model. So it only listed under test model and not, it only listed under compile folder and not the run folder. If you run dbt run command, then you'll see that .sql file in compiled and the run as well. Like this one, test connection, we actually run dbt run, so it has this one as well. Create view dbt warehouse, and the schema it will get created, which is dev schema, and the query select one as connection test. That is how it works. We will talk about these files later, about the manifest, about what manifest is, and stuff like that, about the metadata later. But for now, this is just about the what? Discoverability. Yeah, the node discovery. So we're done with this lab. Now, if we scroll to the bottom, it's here. So what we learned is file existence inside models controls DAG membership, obviously, and dbt automatically registers .sql files inside models as nodes. Okay, just under models. Okay, no file equals no node. If there is no files under models, there are no nodes in the DAG. And the DAG is file system driven. That's it. And the next one we are going to talk about is macros. From here, it's going to be quite interesting to learn these topics. Up to now, we just talked about models, which is nothing but the basic transformations that we write in .sql file format. But macros is something different. It contains reusable Jinja logic. Like I said, we use Jinja templating, right? So we use Jinja logic here in macros, which is reusable. Does not create DAG nodes. So whatever you create in macros doesn't have ability to create a node in the DAG. Registers callable functions. Macros are logic factories, not transformations. They just contains of clusters of logic basically. They only have logic, they're not actual transformations. If a macro file is placed inside models, dbt will treat it as a model. By the way, to make it so simple, a macros is nothing but a function that we use. Let's say, if you know about Python, we create functions, right? We define functions first, and we call the functions whenever we need. So we reuse the same logic again and again by calling the function and passing the parameters to it. In the same way, the macros are nothing but dbt's functions. So we create them, they are reusable. So if you think any particular logic will be reused multiple times in that particular project, you can just create a macro file for that using Jinja template, and then reuse the same logic again and again by changing the parameters that you pass to that macro file. That's how they work. They're basically functions. That's it. And yeah, we have a lab for that. We're going to create a macro file. Let's head to that. Let's open VS Code. Now, we don't use models here, we use macros. We are going to create a new file under macros and name it test underscore macro.sql. And what I'm going to write here is, like I said, it follows Jinja templating. You might get confused what I'm going to write here, but bear with me. You might not understand it now, but we will talk about Jinja later in the later module. I think it is somewhere around phase 4 or phase 5. I'm not sure. We will talk about Jinja. So yes, just bear with me. I'm going to explain what I do here, okay? This should be flower brackets. Well, this part is plain SQL, but this part is Jinja. We will talk about it later. What we're doing here is we're just creating a simple macro file where when we call it, it just selects one as macro column. Now we save the file. Now this doesn't take any input parameters. This is just a simple macro file that I created to show you what happens if we misplace this macro file inside models folder. So I'm going to cut this file from here and paste it under models. Now, because that macro file is under models, it is considered as a model and not macro file. To show that in reality, if we run this command again, dvd compile again, see that? Now it says 3 models. And that is why placement of the file is so important. And if you misplace those files, they are considered as that type of file depending on the location you save that file at. Well, you might thought I'm going to create an actual macro file and demonstrate how macros work, but we're not to that extent yet, but I will show you how we create a macro file, how we use that reusable macro file to get output from it later in the later modules. But now this is just a misplacement test. So, and that's how it works. But under target compile, it is not compiled because it is just a macro file. It cannot be compiled to, it is not a normal transformation, so it is not listed under compiled here. Okay, that is it with this lab. Now we talk about seeds. Before that, let me just delete this macro file so we don't get confused in the later demonstrations. Okay, now we talk about seeds. Seeds contain CSV files. Each CSV becomes a table using dbt seed. Basically, if we want to include a CSV file into our project, we place it under seeds folder. Seeds are nothing but CSV files that can be that can have versions in it. Not versions. I'm not sure how to say that. Basically, we can just save a CSV any CSV files in the under the seeds in the seeds, and when we run dbt seeds command, these CSV files will be converted into a table and saved in the database. So I'm going to demonstrate how that works as well in this lab. Let me go back to VS Code editor. Here under seeds, we are going to create a new file and name it, let's say countries.csv. And this file will have, because it is a CSV file, it has the first line of it should be the column names, the headers, right? So it says country code and country name. That will be the column headers. Now we type in the countries, the list of countries. India. And then we say United States. And let's add UK as well. United Kingdom. And let's save this. We have the CSV file ready here. So we have a CSV file under seeds now. Now when we run dpt seed, which means here we replace compile with seed. Now we run dbt seed. Okay. Now this will create a table with the data from that CSV file. Now it ran and it found two models. That's correct. And one seed. We just we just created a seed, one seed, and 101 start seed file dev underscore schema dot countries, and okay, loaded seed file. So the seed file is loaded at dev schema dot countries. So this is the table name, dev schema dot countries. Now we can verify that from the database by connecting to the warehouse. Right? So let's connect to the warehouse using this command again. Here, let's type in select all, which is asterisk, from countries, and the semicolon at the end. Run it. Oh, my bad. That is because I haven't included the schema name. We have to route to that table, which means we also have to include the schema name in the query, which is dev underscore schema. We copy the whole thing, paste it, and end the transaction using semicolon at the end. Now run it, and there you go. Now our warehouse has a table named countries under the schema, dev schema, because the target is by default is development, and the table has two columns, just like the .csv file. One is country code and the other one is country name. And that exactly matches, right? And for the first row, we have IN as country code, India as country name, and US, United States, UK, United Kingdom. 3 rows. I think now you know how seeds work. Now let me just exit from this warehouse. Head back to where we stopped. Now we're done with this lab, seed materialization. We've done all that. And there is snapshots folder where we can define snapshots, which is nothing but a model to save row level changes of a data. Basically, we use snapshots to implement SCD to slowly changing dimensions, where a row can be changed in the future in a particular data, and you want to capture the old one and the new one as well. So that is why we use snapshots. We will talk about snapshots deeper later in the later modules. I think it is at module 8. We'll talk about snapshots more. And then there are tests. Contain singular SQL assertions. A test passes when it returns 0 rows. So if you want to run any tests on the data source that you get, you can define the test under this folder and then run those tests to that data source. And only if the tests return 0 rows, which means there is no errors, only then it will pass, or else it is not passed, it is blocked. We will talk about tests as well later. And then we have target. We already talked about target is generated and when only when you run dbt compile or dbt run commands like that. It contains compiled SQL. We already talked about compiled SQL, which is this one, and then manifest.json, which is this one, and run results.json, which is this one, and logs. All these are basically metadata of what we execute. And these are never version control, which means this folder, this whole target folder should never be made to GitHub. It shouldn't be saved in the Git repository. And that is the reason why we include target in .gitignore here. That's the whole reason. See that? So delete safely. If you want to delete it, we can delete it. And regenerates on execution, only on execution. If you don't execute anything, we just create the models, nothing gets created. The target folder itself will not be created. And then in dbt packages, this is something that we talk about later, where we talk about importing dbt utils from any external source, like an external community, where we can import those utils, dbt utils, and we run dbt deps, which creates this folder then, dbt packages. We'll talk about it as well. Logical layering strategy. Inside models, this hierarchy should mirror transformation flow. The best way to best layering strategy we can use in models is this: staging, a folder for staging, which will be the staging the staging layer, which is basically the raw data saved. I'm not sure how to yeah, just the raw data saved in the source, and then there is intermediate, where we transform, where we do the cleaning stuff. Basically that will be the intermediate layer, and there is marts, which will be the final transformations to make the data business ready. This is kind of similar to the medallion architecture, the medallion storage architecture, where we use the terms bronze, silver, and gold to differentiate between the data purity. Here we can use staging, intermediate, marts. Marts will be the final transformed business ready tables or views. This hierarchy should mirror transformation flow. Conceptual layer diagram, raw sources. From raw sources, staging, which is standardization, it just saves the data in tables or views. And then intermediate, which will be the business logic, and marts, consumption ready outputs, which is business ready output. Okay, we also have layer wise explanations as well. We have staging layers, one-to-one with raw tables. So just the raw data from the data source stays stored in the destination. And then we have minimal transformation. So there is no transformations done. Renaming, casting, cleaning. just the basic transformations, and then goal normalize inputs. That will be like that, and the files that we save under staging can should be in the way so we don't get confused over it. So the files that we save in the staging folder should go like this. It should say stage underscore order, something like that, so we don't get confused. So every file under the stage should follow the same format. They should have some sort of format. And this is the most used one. We can just say stage underscore orders or stage underscore customers or something like that to represent that staging models. And there is intermediate layer where we can do joins, the big cleaning step and transformation step, business logic, aggregation, preparation, reusable building blocks. Example, int order matrix.sql. And this is a this is a optimal file name format. It should start with int underscore or something like that for every file that is saved in this layer. We have marts layer, fact tables, which basically have fact tables and dimension tables. Facts and dimension tables are nothing but if you know about this method that we use, where the final business ready data is in star schema. I hope you know about star schema, which has one fact table and multiple dimension tables connected to that single fact table. That is what we're talking about here. So there is one fact table that connects all the dimension tables. So we separate the data into multiple dimension tables and connect all those dimension tables with one single fact table. And that is what we call a star schema, because there is only one common connector between all the dimension tables. And the optimal file name should be can be fact underscore sales dimension underscore customers.sql. So there is nothing but the formatting the models in the right way. That's it. Nothing technical. These more about practical and making it readable and also sustainable. Building a sustainable system. Naming conventions. We talked about naming conventions. If the files are under stage, it is good to start with something like stg underscore something like that. So this is good. stg orders, int customer matrix, fact sales. We can just say data.sql because that is so confusing. And then we talk about configuration inheritance. We already talked about this when we configured the dbt project.yml file. But here, now we're going to practically demonstrate how the inheritance work. I said we can declare folder level materialization as well, right? And that is what we're going to do here. We're going to create one folder for staging and one for intermediate, one for marts, and then we edit the dbt underscore project.yml file and paste this there. So we declare staging as staging materialization as view and intermediate as view and marts as table, and run and save one file in each of those folders and see if these materializations are actually effective on those. Because like I said, because we define the materialization in staging as view and intermediate as view and marts as table, everything that every SQL file that we execute in staging should create a view, and everything in intermediate should also create a view, but everything in marts should create table. Okay, let's head to that lab. Let me close this and the CSV file and this one as well. And also, to not get confused, I'm going to delete all the models that we created, every one of them. I'll keep the seeds, that's fine, but I deleted all of them. And I'm going to delete the target as well, the whole target folder. Just to make everything fresh. So I deleted all the models and the target. And now let's head to dbt underscore project.yml and change this so we define the folder level materialization here. So we said dbt project and a tab staging. We haven't created the folder yet, but we will. Okay, and we have to give a tab space here. Okay, and same thing with intermediate. This is also materialized as a view. And this one, which is maths, will be materialized as a table instead. Now save that. And now under models, we're going to create those new folders. The first one is staging. The next one, let's say maths. And one more folder for intermediate. Now create one file, one .sql file for each of those layers. For staging, first for staging, we create test view.sql. Or let's say, let's rename it as stg underscore, because the naming format we just talked about it, we cannot breach that. So let's say with that and a basic SQL code ID, save that file, and one for intermediate, new file. I'm going to name it the same way, int test view.sql with the same code. Save. And the same thing with the maths as well, new file. I'm going to say fact here, fct test. I'm going to name it test table because it will create a table .sql. Run it. And use the same code for that as well. So all of these transformations just create a table or a view with one column and the column name as ID and one row with only the value as 1. That's it. But the materialization is different from staging and intermediate to fact table. In the staging and the intermediate should create views, two views, and the fact should create a table. Now, after saving all these files, We open PowerShell and run dbt run here. So here we instead say dbt run and copy this line, paste it here, run it. Okay, now this got executed. Created view, create view. Even here it says, for intermediate, it says created view, and for staging, it also says created view. But for the fact test table, which is the marks, it only says select one in 0.1. So it never said it created a view. And here it says finished running, one table model and two view models in whatever the time it took. So it does specify what got created, but to make sure everything went fine, we are going to connect to warehouse now. To connect to warehouse again, we use the same command, connect, and we run a command to print the list of tables and views. So this now this command will print all the tables that are listed under dev underscore schema. Run it. Here we can see there are two tables. The first one is countries, which got created from the seeds we did before, remember? And there is only one table that is other than seeds, which is fact test table that we just created with this one. Okay, and in the same way, we say dview to print all the views, and copy paste this part, and this will print all the views. Dev schema, in test view, stage test view, and test connection. These are all the views. And this test connection view is created at the beginning of the masterclass. And these two are just got created. And the type, here it says the type as well. And that's how, I forgot the lab heading. Okay, that's how the configuration inheritance work. Okay, we're done with that lab. I think we're done with this module now. Well, this is a lengthy module, but as we go, the size of the modules reduce, but the topics get more and more advanced. Now, with that, we're done with this module. Let's head to the next one. And now our next module is dependency graph and DAG mechanics. And we are going to talk about ref of resolution, this one. Remember when we talked about DAG, direct acyclic graph, whenever we run dbt, it creates a DAG, it creates a DAG graph, which is a graph. It looks like a flow chart between all the models. So in this module, we're going to see how those nodes get connected and how it works. Okay. Now first we have to know about ref of this, and the purpose of it is it creates dependency edges, resolves physical relation names, determines execution order, enables environment isolation. If I have multiple models, if I have multiple .sql files under models and I want to connect those models together, so those models follow a flow of those models follow my desired flow. I can control it by using this ref of. Without ref of, there is no DAG. And how this ref of works is, let's take an example. We have a data. Okay, we have a data, and from that data we create a staging table. Let's say STG orders, like it says here. So it creates a staging table, STG orders. Okay, like this one. Okay, and then we also write an intermediate layer, which should be related, which should be dependent on the staging orders, because this is the staging layer and this is the intermediate layer. So the data from this layer should be transferred, or should be used, should be consumed basically into this intermediate layer, and here we do a few transformations, right? And to what to say and to establish a connection between these two, we use ref of. So in the intermediate function, intermediate.sql file, I write something like this. I say select, and I write the logic, and then I refer to this staging orders table using from, I shouldn't say table, but this staging orders model, by writing this from of, this is Jinja template. So we use flower brackets here and say ref ref. So we are just referencing the data from stage STG orders model. So we refer the data from STG orders model, and we get that into this one, which is the intermediate stage. So that's how we connect the models together. We use ref of. And without this, there is no DAG file at all. There is no DAG. We shouldn't call file. There is no DAG created at all. We should have this to create a DAG. And that is how we assign relation between models. To be very clear about this, because we have to be clear about this, or else this is going to be confusing later. What I'm going to do is I'm going to create a basic or simple DAG file, or a simple DAG, to show you how that works. What I'm going to do is I'm going to insert a shape here, something like that. I don't like this color. And here, let's say this is a node in the DAG, okay? And this will be STG orders. And there is another file, other node underneath it, and it says it is the intermediate layer. It says int orders, maybe the same, but this is the intermediate layer. And there is another model underneath it, which depends on the intermediate layer, which is the marts layer, and it is something like facts orders, and these three are connected using ref of. So we use ref of STG orders in intermediate orders, and we use ref of int underscore orders in fact orders, and that's how we establish the connection. And now these are all connected together. Let's insert another shape. And like I said, a DAG is nothing but something like a flow chart. It goes like a flow. So first the stage orders will execute, and then it goes to intermediate orders, and that will be executed, and after that it goes to the fact orders. That's how the flow of execution works. And these are a DAG somewhat looks like. And there can be multiple nodes that are related. So each one of them are called nodes in a DAG. And this whole thing is a DAG, direct acyclic graph, and each one of these blocks are called as nodes, and these are dependencies. So now int orders have dependencies, has one dependency, which is stj orders. Without stj orders, int orders is not existed. If something fails in the upper node, all the downstream nodes will not be executed at all. If the stj orders failed, int orders will not execute and factor orders will not execute as well. That's one thing. And by the way, this is a simple DAG, but there can be multiple nodes connected to one source. We should not call it source, one model. Here, now STG orders is only acting as a dependency for int orders alone, but it can also act dependency as to multiple nodes. We can just use ref of STG orders in a different model and it still works. But this is the basic one. This is how the dependency graph or a DAG works. Now, I think now you got the idea clear about the DAG. There you go. Here it explains more clearly. So here we took an example where we select everything from ref of, we're referencing STG orders, an order model in the staging layer. Now, when we write that, it finds the model named STG orders, okay? Registers a dependency edge. It registers the dependency of this model to that STG orders model. Resolves the fully qualified relation name and replaces the Jinja call with compiled SQL. Like I said, whatever we write in a model is not completely SQL. I already talked about it before, right? Because this is not part of an SQL. This is not part of SQL, right? So this will be compiled later from Jinja to SQL, which is executable in the warehouse. We will be seeing an example of that in this very model. Okay, that is how it works. Now the conceptual diagram will go like the logical reference, int orders matrix. So the int orders is dependent on stage STG orders. The physical resolution will be, this will be the compiled version of it. Here we just, in int orders, we just write in the using the Jinja template like this, using flower brackets and say ref of STG orders. When it is compiled, the physical resolution, which is the compiled version, would look something like this. The database dot the schema name dot stg orders. This is how the compiled version looks like. I will show exactly how it works in the lab, but yeah, that's the idea of it. Now, internal mechanics, node lockup, a node lookup, dependency registration, a relation resolution, graph update. Okay, there you go. Now we entered the first lab 1 for this module. Let's head to that. Okay, again for this lab, I'm going to delete all the models, not the folders directly, but the models alone. I'm going to delete all the models. Okay, just so we don't get confused, and also the target, the whole folder. I'm going to delete the whole target. Oh, wait, did I chosen the right one? Delete the whole target folder. Now create a few models in these 3 layers. Starting with the staging layer, I'm going to create one file here. STG. Let's go with the stg underscore orders dot SQL. Create it with simple query, which creates 2 columns. So I'm gonna write select one as order ID, comma, 100 as amount. Now save it. So this will create a table, or no, sorry. This will create a view because it is under staging folder. It will create a view with two columns, order ID and amount. And each of those columns have, I mean, the whole table has only one row with 1 and 100 as values for the first row. And under intermediate, I'm going to create another file named int order matrix sql matrices. And here I'm going to say select order ID. Now that shouldn't be kept. Order ID, comma, amount, and say amount times 0.1 as tax. Now everything up to here is just SQL. Now we're going to use Jinja for referencing and establishing a connection to the stage STG orders. To do that, we say from double flower brackets, and then we say ref reference of STG underscore orders. Now this will establish a connection between them, the dependency between them. Now save this, and another file under marts, and I'm going to name it fct fact sales .sql, and inside select order ID. I'm going to call it amount, and let's say tax. Amount plus tax, just a calculated column as total amount from, again, double flower brackets, and say ref reference from int intermediate order matrices, and a space here. Okay, now here we got three models created: staging, marts, staging, intermediate, and marts. And the STG order is fact sales is dependent on int order matrices, and the intermediate order is dependent on staging orders. And that's how the dependencies work here. And now let me just save this and execute dbt run. Before that, we have to exit this warehouse and run the command dbt run. Now here, when we run it, you have to see the execution order here, because whenever I execute dbt run, what dbt does is dbt parses whatever I've done, then it creates a DAG graph. So according to the graph, it should go in this order, right? In this order, it should start executing stage orders. After executing stage orders, it should go to the intermediate and then go to fact. It cannot start with, it cannot go, it cannot start with fact orders at the first and the second and third. It cannot go in the reverse order, or it cannot go, it cannot start from the middle, because that doesn't make sense, because intermediate orders cannot be executed unless and until staging orders is executed. So the staging should be executed because intermediate is dependent on it. Only then intermediate layer can be executed. That's how the DAG flow goes. That's how the DAG flow works. And here, in our case, the same thing should happen. First, it has to execute STG orders, which it did, right? STG orders, and it created STG orders view. Right here it says create view, and then it goes to intermediate orders matrices, right? That's second in the flow, and then it created the view for that. It says create view here, and then it goes to fact sales, which is the last node in the DAG, and that will create fact sales table. Now it finished with one table creation and two view creation. Okay, now we know how DAG works. Let's head to the next lab, which is lab 2. We're done with the lab 1. With now we head to lab 2, direct acyclic graph. No, sorry. The lab 2 is inspecting the graph. Okay. To inspect the graph, we run something like dbt-ls, something like this. Instead of dbt run, we say dbt-ls. Copy that. So it lists all the nodes in the DAG. There you go. Shows everything, and then no, sorry. So it just lists the models, and it doesn't care about, not just the models. It lists everything that is in the project, and it doesn't care about the flow here. So it just lists, because and that's why we have marts at the top, intermediate at the next to that, and the staging next to that. But if we run something like dbt list, and if we say select STG orders and say plus, what this does is it only prints everything that is in the downstream of STG orders and STG orders. That's it, and nothing else. Now when we run this command, it only prints the downstream of fact sales. Here, if you see the difference between these two, here it prints fact sales, intermediate orders, matrices, and stage orders. Everything's fine. And it also has countries, which is the seats, DBT project, which is part of the seats. But when we write this command, which says only select the downstream of stage underscore orders, it only prints the downstream along with the stage orders and nothing else. Here it says marts the fact sales, because that is part of the downstream, and int orders is also part of the downstream, and STG orders, which is at the top of the stream. So only the stream part. Now let's see that with another example. The same one, but with a different scenario. Instead of printing the downstream, let's print the upstream of fact tables, fact sales, using plus FCT sales. So it depends on where you place this plus symbol. If it is at the front of the model name, it prints the upstream. If it is next to the model name, it prints the downstream. If you include both if you include plus at both the ends, it prints the upstream and the downstream. Now I'm going to execute this, and later I'm going to show you with the intermediate model to see how that works. Now here it prints the same output because the upstream should include everything. Okay, it prints the same output as this one, but now we are going to switch this a little bit, and instead of fact sales, we are going to use int order matrices, which means it only prints the upstream of int order matrices. So we can only see staging orders and int order matrices and not fact sales. And there you go, it only prints two of them, right? Now if you want to print the downstream the same way, you have to remember this because we are going to use this for a particular application later. So this is a prerequisite for that. Now we're going to print the downstream of intermediate model, which includes the intermediate model itself and fact sales, which is the MATs, and not the stage orders, because stage orders is the upstream of it. Now the final example where it prints the upstream, both upstream and the downstream. By enclosing that with plus on both sides. Now it only prints this particular stream and not it will not print this one, this seed's name, the countries. It prints everything that is belongs to that particular stream and nothing else. If there is another DAG file separately, separate to this stream, that will not be printed. Only the stream, only the models that are part of this stream will be printed if we add plus on both sides of a model. So it prints everything in that stream. That is how it works. And now I think you got it. That's it with the second lab. Yeah, I forgot to talk about the compilation, right? And this is why we use ref. Without reference of without ref off, dbt compile fails immediately, clear error. With ref off. If we don't choose ref off, the dbt will break silently and runtime failures happen. So if we want to know any failure happens in that flow, we use ref off to reference any model. Now, because we executed dbt run, these models should be compiled first, yes, and then should be run, which means under targets, we can actually see all the models listed under the compiled, and we can actually see the compiled versions, where this whole thing, which includes SQL and the Jinja template integrated together, will be converted to just SQL executable format. To see that, I'm going to open stgorders first. Well, this is same because we haven't have anything other than SQL in the actual SQL actual STG orders, so there is no change in this. But let me close these two. Now let's open compiled version of intermediate order matrices and compare this with the actual one that we wrote. This is what we wrote. The compiled version is this. This is fully SQL now because this is compiled and made SQL executable by dbt. You see that? the whole Jinja template, the whole Jinja part is replaced with SQL. See that? And that's how it works. And this can be executed in the warehouse, right? But this cannot be executed because SQL cannot understand Jinja. That's how it works. The same way for the fact sales. You see that? Let me close these two and compare the fact sales now. This is not executable by warehouse, but this can be executable. That is how it is compiled. In the same way. So this is the exact part we run in the warehouse. Okay, we're done with that. Now we know how the compilation works and how the DAG works. Head back. Now part 2, direct acyclic graph behavior. What the DAG is. Direct acyclic graph where nodes, model, seed, snapshot, tests, edges or dependencies from ref of or source of. The dependencies can be ref. We use ref to reference between the nodes that are inside DBT, but we use source of to source the data from outside DBT, from an external source. That is how source of works. We will work with it also. Okay, and then directed flows only one way. We talked about it already. It flows, the graph flows one way. Acyclic, no circular references, which means we already talked about this. So this flows one way, right? This thing only flows this way. What if I add in the STG orders model, what if I add ref of FCT orders? What happens? Now, what happens is this, right? This will be dependent on this one, right? So which forms a circle? A cyclic flow. That cannot be happened because that doesn't make any sense. And that's why he says acyclic. A DAG cannot be circular, cyclic. And that is why it says directed acyclic. Directed is directed. The part directed means it flows one way, and acyclic means it cannot be cyclic. And edges means the dependencies between the nodes, basically the blocks, and the nodes are nothing but the model, seed, snapshots, tests. I think now we got it. This is the whole definition of DAG. Okay, DAG construction process. When we run DAG dbt run, it passes all the model files, identify Jinja cells, like we wrote here. This one. So it identifies the Jinja cells, right? And then registers dependencies. It registers the dependencies according to what we define here. It registers them. Detect cycles. Build graph in memory. It builds the graph in the memory, topologically sort, and execute nodes. And it starts executing the nodes in the flow by following the flow. And the graph metadata is written to manifest.json. That is what the manifest.json file under target has. So when we run it in the target, this file will also be created, and this is where the actual DAG is created or saved. But usually this manifest.json will be so long that makes it inhuman to read the whole thing or even understand it, because it's so lengthy. But why we need this is what DBT's basically, this is the DBT's brain. This everything that happens in DBT's brain. It follows this manifest.json. It creates it and it follows this. This is basically its brain. We don't need to use it. DBT will use it. But we can, in few cases, if we want to debug something that is only possible with manifest, we can. But I don't think in rare cases we can. See that? It is so lengthy. You cannot. It is even more. It is not the end. This is not the end. It has even more. It is so lengthier we cannot read it. So this is where the DAG is saved. That's the basic point. That's the whole point of showing that to you. Now the conceptual DAG example. Raw orders, which will be the source, we connect the source to stage orders using source of we talked about before, which is, where is it? This one. We use source of to refer to the source in the stage orders, which is raw orders. And then we refer stage orders in intermediate order matrices. And we refer to the intermediate model through the fact sales. That is how the whole thing is connected. And these are the principles or the rules that the execution follows. A node executes only after parents complete. Like I said, it cannot execute from the bottom. It should execute from the top. And only if the top layer or the upstream executes, the descendants will execute later, or else the whole thing will be cancelled. If something at the top pops or triggers an error, the downstream will not get executed. Independent branches execute in parallel. Let's say right now we have a DAG with only one single stream, right? Because all these models are connected to each other. So we only have one stream. And now let's say I create another staging model and do not refer to anything. I create another intermediate model to refer to that staging model and not this one. So a new intermediate model with a new staging model connected together. So these are two parallel branches. They execute in parallel. So they don't wait for one branch to execute and then start. They just execute parallel to each other. The first node in this branch will execute, and at the same time this can also be executed. And yeah, and it moves on. Concurrency limited by thread count, and the concurrency is limited by thread count. It depends on how many threads we define. The concurrency of these branches depends. The concurrency is nothing but executing at the same time, and it depends on how many threads we define. We define 4 threads for development environment and 8 for production environment. So we can run four branches at the same time, basically. Okay, now we have the third lab, which demonstrate parallel behavior of branches. Okay, now let me demonstrate that. Now I'm going to create another model, another file, .sql file under staging, and name it stg customers.sql, and say select one as customer ID, comma, and say JOHN, John as customer name, and save this. Now here we haven't referenced anything. We haven't referenced anything in this model. This is just an independent branch now. It has nothing to do with that branch, that stream. This is an independent stream or independent branch that we just created. Now when we run the dbt run command again, let me just take this down. We don't need this, but say dbt run, copy paste this line, run it. Here, if you take a close look here, you see both the staging models executed at the same time. This staging stg customers did not wait for stg orders to execute. You see that? They both executed parallelly on the same threads. And stg customers used the first thread out of the 4 threads, and the stg orders used the second thread out of that four threads. So they basically executed at the same time. And that's how parallel execution works. So only the nodes that are on the same stream wait for the upper stream to be executed. But if that branch or stream is independent, it just starts right away. It executes parallelly. And with that, I think we're done with this module. Now let's head to the next one. Yeah, let's head to the next one. And for our next module, we have module 6, materialization and incremental strategy. We already talked about materialization. We talked about tables and views, but we are going to talk about a new structure, which is incremental table. Here, say we have a conceptual diagram. Okay, now it says conceptual separation. Okay, so now a DAG is created on the basis of ref of, right? So that says the dependencies, that defines the dependencies, and then the execution order. Now following the DAG, the execution order is determined, and after that the materialization is done. After executing everything, it defines or it decides what materialization should to implement on that particular output. If the materialization is defined as a view, that will be saved as a view, and then it is saved as physical object in the PostgreSQL, which is the warehouse or the source that we defined. So the materialization is done at this part of the process. What materialization is? A materialization is a macro that determines how SQL is wrapped in DDL, whether an object is recreated or updated, how dbt handles existing relationships. By the way, for this point, whether an object is recreated or updated, we will talk about it right now because it depends on the model that we use. Those table or that particular structure will be recreated or updated accordingly. And how data handles existing relations, whether persistence is full of potential. In PostgreSQL, the 3 core strategies are view and a table and an incremental table. So these are the 3 ways to materialize the output. Now talking about the first strategy, which is view materialization. Before we know about the incremental table, we have to know about these two clearly so we don't get confused. Firstly, a view is created as in this way. In SQL, you can write create or replace, or you can just say create view and the name of the view and as and the definition of that view to create that. And here's the thing. When you create a view will not store any data physically. What it does is it just stores the logic, and whenever you want to query something from the view, it the view is basically connected to a source, and so that the view is not will not store any data. So whenever you query a view goes back to the source and get the data from it and then print the output. That is how a view works. It will not store any data in it. And when to use staging layer, so you can use view at staging layer, lightweight transformations, rapid iterations, small data sets. So you can use that for small data sets. So all these uses. So this is how a view work. It will not store anything physically. Now internal behavior on dbt run, if view exists, it replaces it, no table drop. If the view that we created already exists in the location or in the destination, it will replace the view with the new updated one. So there is no table drop. There is nothing. There is no table drop because we are just replacing another view and not dropping a table. And no data storage because a view doesn't store anything, any data in it. Advantages: minimal storage. No matter how many transformations you do, the storage will be so minimal compared to table. It is drastically minimal. Always reflects upstream changes. So whatever changes in the upstream, which means basically the source it is pointing to changes, the downstream, which is view, will automatically update within seconds. Fast rebuild. And the risks: every downstream query re-execute logic. And the risk is anytime you query from a view, it has to re-execute everything in the source and get the output from it and then print it to you. So it creates a complexity internally but not externally. And also it takes too long to actually give you the output because it has to refer to the source and get the data from it. And that is a downside of view. Now we come to table materialization. This is how we create a table. We can just say create table, schema, and the table name as and the definition of the table. And here, unlike view, table does store the data. So it does store the data. When to use final marts. So when we use it, we can use that for the final data, the final marts. Expensive, it is expensive aggregate. Expensive aggregation, frequent queried outputs. So when you query from that particular table or a data frequently, it is better to create a table because if that is a view, like I said, it has to go to the source and get that data from it. So it is so slow and it makes the job even complex. Internal behavior: when we run a model that creates a table, it drops the existing table. If we already write for example, we already ran this model, right? And third one, which is fact sales, actually creates a table and not view. The rest of them creates views, so that's fine. But this one actually creates a table. Now what happens is when I run dbt run again, this execution will replace the table that is already stored in that location with a new table. It creates a new table and replaces it with that. So it drops the table first and recreates the table. So it recreates using create table as select and all the definition. So it recreates the table by dropping it again. So full rebuild every execution. It rebuilds, the table gets rebuilt for every single execution, whereas view is not. So that is how table works. But table is so fast, and that's why it says fast downstream read. So it is so fast because it doesn't need to go to the source to get the data like in a view. So it is so fast because the data is stored locally. Computation happens once. Stable analytic surface. it is stable. And the risk full rebuild cost every run. So for every run, the full rebuild happens, and that costs a lot more than a view. Large tables expensive to refresh, longer execution time. That is how the tables work. Now, coming to these two, tables and views are the basic models, or the basic, what to say, basic structures in SQL in a database, in a basic database. But here, now we are going to introduce incremental model, incremental table materialization. Now this is quite different. It has the features of table and also the efficiency of view. Did I say it correct? Let's say let's go to the definition. Okay. What it does is it processes only the new and changed records instead of rebuilding the whole entire table. The first thing we have to know about it is, just like the tables, incremental tables also store the data locally. It don't go to the source, it don't refer to the source. So the data is stored locally, but it only gets updated and not recreated every single time. Whenever, so let's say with our same example, instead of materializing these marts as tables, if we materialize this as incremental, what happens is, if I run it first time, it just creates a table. If I say incremental table, incremental materialization, for the first time it just creates a table because there is nothing exist in the warehouse, so it creates the table. But when I run the same model again, and there is some new data coming in, what happens is, instead of rebuilding the entire table by dropping it, what happens is it only takes the new records that are in there in the output and updates the already existing table and adds them. And that is how fact sales works. And if you run it and there is no new records at all, it will not do anything. It will just stay as the same. And that's how incremental tables work. And when to use? When there are large data sets. Imagine if you have if you have a small data set, a table or a view or anything doesn't matter, because a table can be rebuilt multiple times whenever we execute dbt run, and that doesn't cost us anything because the data set is small. But when you work with a data set that is so large, if you have millions of data or millions of records in that table, dropping the table and recreating the table every single run is so expensive and takes so long. And that's why we can use incremental instead of a table or a view. Here, when to use append heavy tables, when to use includes append heavy tables. So we can use that for appending heavy tables and slowly growing data. The data that grows so slowly and not exponentially. Expensive full rebuilds. Because the full rebuilds are expensive, we can use incrementals. That is how it works. Configuration. Okay. Well, until now we saw how to configure how to materialize the models in the folder level. But now here we're going to see how to materialize the model file level. If we want to materialize the output of this particular file alone, we can use this way. We can do that in this way. You can use this Jinja template and say config of materialized and equals incremental. So materialized is incremental, and the unique key will be order ID. This will be acting as the unique key. That will be the unique identifier for each record. And that is how it calculates if there is any new unique keys entering into the table, those rows or those records will be considered as a new data and then will be incremented. So this will be the unique key, and the materialized as it is materialized as incremental. We say select the same and then reference, and then if is incremental where order ID is greater than select of max of order ID from this, and if here we are using Jinja to just see if you have any new data. Every time we execute, we see if there is any new data exists. I mean, new data is coming in. We do that by using where clause and say order ID. So it picks the order ID is greater than select max of order ID from this. So the current table that is getting, what to say, ingested into the warehouse will be represented as this particular part. So this will say this current table, and then max of orders, the max of order ID, if the that is less than this order ID, that confirms there is an incremental data. There is a new data coming in, and that's how this will exist. Sorry, this will execute. We will run something similar to this in the lab that is coming up. Okay. So here's the thing. And because incremental tables are not rebuilt every single time, but if you want to rebuild the table when you run a command, you can run this command. You can just add full refresh right next to dbt run. So what this does is it drops the table, even no matter if it is an incremental table, it still drops the table and rebuilds entirely. And that's how you do it. And there you go. Now we're in the lab part. Let's do that. To do that, I'm gonna head to the VS Code editor again. Here, I am going to open mods factsales.sql, close the rest. I'm going to do some modifications to this code, this query, by adding say config materialized equals incremental, and then that we write the conditional logic and say if is incremental of I keep forgetting to write them as capitals to make it more readable. So it doesn't matter in SQL if you write these things in capitals or lowercase, but just for the readability, this is better than that. And then at the end, we end that if, like that. Save it. Now we run dbt run again. Copy this. We run dbt run. For the first run, because this particular model is not created as an incremental table, because it is created as a table. Now everything is rebuilt again. It drops the table and creates a new one as an incremental table. Okay, right here. So it says create SQL incremental model and fact sales. Now when we run that again, now here, there is nothing to insert, right? So it says insert 0, 0. So there is nothing to insert here. But we're going to try inserting a new record into the table and then see what happens, okay? For that, we go to the staging stage orders.sql file, and we added one more. We add one more record to it and say to as order ID and 200 as what? Amount. Now save it. Now here we are adding one more new row with 2 and 200 as values. Now when we run this, when we run dbt run again, there you go. It runs and now it inserts one record. It will not rebuild the whole entire table. Well, it says here, it says created SQL incremental model, but it doesn't actually rebuild the model. What it does is it just inserts that particular row alone. And here in this case, it is just one row, so it says one row inserted. And here it says inserted 0 because there is no new rows inserted. And that's how incremental model works. Incremental table works. We're done with this lab now. There's one more thing I want to talk about is this trade-off comparison. So this compares the trade-offs between all those structures, basically the materializations. Here it says the difference between the views, tables, and incremental table. In the sense of storage, views doesn't occupy any storage, so it says none in the storage. Whereas table, it occupies full storage, and in incremental, it only occupies partial storage. And then the rebuild cost for view, it is low, and for table, it is high. And for incremental, it is low still, right? Because table is rebuilt every single time, the cost is high for the table alone, and for the rest, it is low. And for a view, the query speed in the sense of query speed, the view is so slow to query Whereas the table is faster because the data is stored there. And then the same with the incremental model. Two, the data is stored locally, so the query speed is also fast for incremental model as well. Whereas the use case, view is best for staging and table is best for marts. Incremental is best for large fact tables. So it is best for the large tables. If it is a small data table, that's fine that's fine to create a normal table or a view. But if it is a large one, it's better to go with the incremental table rather than a normal table. Those are the trade-offs between the materializations. I think with that, we're done with this module. Let's head to the next one. And all right, for our next module, which is module 7, we have Jinja and macro system. Remember we talked about Jinja and also macros before, and the time has come. Now we're going to dive deep into these two. Firstly, we focus on the Jinja part here, Jinja templating internals here for the first part. The purpose of it is to use parameterized SQL, which means the same things that we used here, the parameterized SQL, which something like that. We use parameters, but it is like parameterized SQL, which is not executable directly in a warehouse. And macros, we use Jinja to create macros, and for variables, we haven't used any Jinja for variables yet, but we will. And then control flow into plain executable SQL. Okay, so it helps all of this to be converted into a plain executable SQL that we can execute in an SQL database. So the PostgreSQL never sees Jinja because it is compiled before it's sent to PostgreSQL to execute. So it never sees Jinja. You see, for example, for this one, we just wrote this in our last example, right? We just wrote this with all this Jinja templating. It is not just SQL at all. Now, when we execute dbt run or dbt compile, this will be compiled and will be converted to this. You see that? This is completely executable SQL. Nothing about Jinja is in this. See that? You see the difference here? Everything is compiled to plain SQL. That is how dbt works with Jinja. So there are two-phase execution architectures. Phase 1, compilation. So it compiles Jinja plus Python evaluation, and compiled plain SQL will be sent to the warehouse. And in phase 2, warehouse execution, these compiled plain SQL will be executed in the warehouse. In our case, PostgreSQL. Compilation happens first, execution happens second. Now, these Jinja constructs are of multiple types, and we used a few of them. Okay, first a couple of them, and the first type is expression block, which goes like this. So it starts with double flower brackets and encloses, close with two flower brackets. So it basically encloses with two flower brackets both the sides, like as in this one here. See that? And also this one. So these two are expression blocks, and they are basically used for ref off, which we did here. So we used that for ref off, and also source off. We haven't used source off yet, but we will. Then we have to use this one. Okay, so remember that. So when we use that, we have to use that, and we haven't used var as well. But when we use it, we use expression block. We will use it. We will use var in the later labs, but now just remember that. And then macro calls. If you want to call a macros, basically Like I said, macros is basically like a function. So if we want to call a macro, we use expression block. Here's the example. We already saw the example in our use case, right? So we don't need this. And this will be compiled to something like this. That's true. Now, the second type of block is control block, which starts with a flower bracket and a percentage symbol and ends with percentage and a closing flower bracket. We use that as well right here, right? And the reason to use it and the use cases are conditions, loops, and logic flow. We use that for conditions here, right? If is a condition, so we use that, define a condition. We can also use the same, in the same way we can also do loops and logic flow. And here's the example. Oh, that's the same example that we already taken a look at, right? So we use the same to create an if logic, if condition. And there is a third type of block, which is comments. Comments are nothing but comments in any other programming language, whereas in Python we use hash to write comments, right? So that is not executed, that is not compiled. When compiled, it is completely removed. The comments are just for the readability. So if you want to add comments, you can say flower brackets and hash and end with hash and closed flower bracket, and you can fill that up with anything, any comment you want, and it will be removed entirely during compilation. So you can just say a flower bracket, hash, and write whatever you want and say, and close it with hash and a flower bracket, and that will be considered as a comment and will be taken off when it is compiled, taken off completely. That is how it works. Okay. Now we have runtime context ingested by dbt. These objects exist during compilation. And the object and the purpose. There are a few objects and the purpose listed here. Let's take a look at that. Extend that a little bit and then to make the table readable. Okay, so the first column here we have for the first column we have objects and the purpose of those objects. First, reference of, ref of, registered dependency. We used it, so we already know it, right? And then source of, reference external table. This is ref of is used to reference a dependency between internal models, but ref of, a source of, is for external table, referencing an external table. And we have this is to current model relation. We already used it right here for the current, to refer the current model relation. So yes, we use that, and we use target to define the active profile target. And then var of, project variables. We haven't used it, but we will use it. And there is environment variable. So this is OS level variable. Var is a variable that can be defined program level or a file level, whereas environment variable can be defined OS level. So it can be accessed throughout the whole OS. Is incremental of, incremental state check. We used it already, right? Yeah, there you go. We used if the state is incremented or not. We use that. So these are Python backed objects exposed in Jinja. So these are basically the Python objects that we can use using Jinja, will be later converted into SQL compatible code or query. Compilation walkthrough, we don't need that. Okay, there you go. Now we entered into the first lab, which is inspect compilation output. Let's do that. Here first, we're going to let me collapse this, and then this one too, this one too. And I'm going to create a new SQL file under intermediate and say int debug.sql. And for the code, I'm going to open a expression block. Is that expression block? So this is control block and that is expression block. Yeah. So I'm going to open an expression block and say config materialized equals and say as view. I know we already defined the materialization for intermediate as view folder level in the project.yml, but just to, because this is just a demonstration for Jinja based entirely, so I'm going to write that again. You can just avoid it or ignore it, that's fine. Say order ID as first column, amount as second column, and say amount of amount asterisk. And now we're going to define a variable here and say var variable of tax rate, comma, and the tax rate variable will be 0.1 as tax. Now we know these are we use variable. See that? And variable belongs to which block? Expression block right here. So we use that. Okay, we did that. Now say from, and let's reference these values from STG orders as well. So technically this particular .sql file is also or node is also part of the same stream, because we are connecting, we are establishing a dependency between this and STG orders. So it also belongs to the same DAG. And then we open a logical block. Is it a logical block? No, control block, sorry. So the control block, say if target dot name, this is going to be something different, by the way, and say dev limit 5, then end if perfect. Now save this. Now what we did here is, first we used, I forgot the name again, the name of the block. So we used expression block and there is control block. Okay, so we used expression block to configure the materialization of that particular file. We don't need this technically, but I just want to show you, I just want to include most of it that is under here, right? Most of it, not the source yet, because we haven't talked about source, but most of it. So we included var and ref, and we also can use configure in the same block, which is expression block. We use that to define the materialization, and we use this selector order ID amount and amount times, and we defined a variable. The variable name is tax rate, and the value is 0.1 for that. And then we multiply that with amount as tax. And then from, we use the same block. We say reference of stage orders. After that, to create a if condition, we use this control block. Is that control block? Yeah, control block. And open an if condition. And the condition is if the target.name is dev, then the limit should be 5, or else there shouldn't be any limit. So if we run this, oh, wait a minute, I spelled it wrong. I just saw it. Okay. If we run this from dev environment or from dev profile, this will, when it is compiled, this limit will be applied to the query. And if we run this from anything, any environment other than, or any profile other than dev, this limit will be excluded. That's how it works. Now let's save that and compile it. We don't have to run it. Let's just compile it. Okay. Instead of run, we say compile. Copy that command. Paste it here. Run it. Now that is compiled. Now let's hit to target, and under compiled, under intermediate, click on the new file that we created. Now compare. Everything is converted to a plain SQL, executable SQL, and this limit is applied to this query, right? Now let's do and also, by the way, oh, here. So this variable, this Jinja, where this block, this Jinja block, where we used expression block, is it expression block? I think so. Okay, where we used expression block to define the variable is replaced with the actual value, which is 0.1. And also the reference is replaced with the actual SQL mapping, the warehouse name, schema name, and the table name or the view name. And now what we're going to do is we run the same command, okay, but from the production environment, the production profile. To do that, we say that, and at the end we add target, say prod. Now this command will be executed in production profile, and that is compiled again. And now, okay, let me close that again and close it and open it again. The same one, init dbt, init debug. Here we can see the limit 5 is removed because we ran this, we compiled this from the production profile and not the developer profile, and that's how our logic worked. Now the limit 5 is not here, it disappeared. Okay, with that, our lab is done. We're done with this lab. Okay, we're done with this one. Moving on. To the next part, which is macros. Now we talk about macros. We actually create a macros and see how it runs in this part. Macros are reusable SQL regenerators written in Jinja. We already know about it. They eliminate repetition. We don't have to write the same logic again and again in the models. Then enforce consistency. Centralized logic, abstract warehouse syntax enables custom materialization. Now, macros compilation flow. Model SQL calls macro. From model, we call a macro, right? And the macro expands into SQL, compiled into plain SQL later, and then executed. So it is compiled. The macro is compiled into plain SQL after combining it into the model and then executed in the PostgreSQL. That is how macros work and the flow works. Where macros live? We already know macros live under the folder named macros, and it looks something like this. We basically what we use macros for. We use macros for the basic calculations that we repeat across all the transformations, right? So something like calculations.sql, utilities.sql, custom materialization.sql, something like that. And a macro looks something like this. So just like we define a function, we define a macro. And we save that definition under the folder named macro, and the definition is saved in a .sql file. So a macro, calculate task. This is basically like a function name, calculate task, and column name, column name. Same like the function, this will be the parameters that we pass to this function. So whatever the parameter that is passed to this function will be replaced with the column name in this function, which is this column name. So that will be replaced, and this column name will be multiplied with 0.2 and returns the output to that location where this function is called, or this macro is called. Okay. It also says how the compilation works. Okay, so let's say this is the basic macro we already talked about, right? And if we call the same macro in this model like this, calculate task of, it sends a parameter, it passes a parameter, and it says amount as parameter, right? And when it's compiled, what happens is it says select order ID and then amount times 0.2. This will be replaced with the logic inside the macro and added to that final compiled output, which is executable in SQL warehouse. These are macros work. These are macros are compiled. Parameterized macros. We just talked about how we pass the parameters, right? The same way. Okay, now let's head to the lab now. Okay, where we create a macro and execute it and see how it works in practice. For that, we head back to the VS Code editor again, collapse everything. Now we're going to create a macro first. Do we have any macros yet? No, we don't have any macros. We create a new file, new macro, and name it metrics.sql. And here, sorry. So we have to define this as a macro first. Macro, and the macro name, which is add margin of revenue underscore COL, comma, cost underscore COL. Okay, and then we open a parenthesis and double flower brackets to represent the parameter revenue underscore COL minus, again enclosed by double flower brackets, column, and the double flower brackets closes, and we alias it as margin. Yes, we can alias whatever we do here in the function or in the macros with something. We alias it with margin. So whenever something calls this macro and passes the parameters, it will be aliased as margin. At the end, we end the macro just like we end the if condition before. We end the macro in the same way and say end macro. That's the end of the macro. Save this. Now we have the macro. But before we execute this, we need to update the intermediate .sql file, which is this one, int order matrices, to actually include that macro in this. But we cannot actually call the macro directly into this because here it uses revenue column and the cost column. And basically what I'm going to do is I'm going to modify the whole thing and create these two, the one for the revenue and the other one for cost. So I'm going to create these two and then pass those two into this macro and then get the output. So we basically are going to modify a lot of things here. Firstly, I'm going to call amount as revenue, and then amount times, let's say 0.6 as cost. So the amount will be revenue, and amount times 0.6, which is 60% of the amount, will be the cost of that transaction. And then that's good. Now from here, because we're creating these two columns, revenue and cost, in this model, we cannot, in this particular entity of table in this model, we cannot directly call that macro right here. What we can do is we can enclose this using a parenthesis at the top and the bottom and alias it with some name. I'm gonna name it as base. Now that's perfect. And from this table, I'm going to create a new table. And that way I can use that macro there. Select order ID, revenue, and cost. And then now I'm going to call the macro, which is named as add margin of and pass the parameters, which are revenue, comma, cost, and save. Now this will create a view, and it creates a view with these 4 columns: order ID, revenue, cost. That's fine. And for the last column, it calls this macro, which is add margin, which is this one. Now it passes revenue and cost. What happens is it does revenue minus cost, and it will be aliased as margin, which means margin will be the 4th column for this view. Now let's save that and run dbt compile to actually see that is working. So we go here, we run dbt compile. Obviously, because we modified this int order matrices, obviously when we run dbt run, we will face some errors because there is a dependency on for marts on intermediate, because this will get data from int order matrices, and because we changed that, we modified that, now the latest column names are more order ID, revenue, cost, and what, margin? Yeah, margin. But here it expects to have order ID, that's fine. Amount, which we don't have, which we will not be having, and tax, which we will not be having because it is replaced with cost, and this one. So this will fail to run because we have to modify this as well, because this is the downstream of int order matrices. But we don't care about that in this lab. What we're going to do is we just compiled, and now let me close the marts and macros, extend target, compiled, intermediate, click on this one. You can see the compiled version of whatever we wrote there, the query. The compiled version has revenue minus cost. So it replaces the function with the actual definition of it, which is revenue minus cost. And this is SQL executable query, right? See that? It is replaced with this logic, which is macro. So it is replaced with this logic. Now, to confirm how this macro works, because this works as just like a function, right? So whatever change that we do in this macro should be reflected in whatever the .sql files that refer to this macro as well, right? So to check that, we are going to add something here and say divided by say revenue column, okay, and save it. Now when we run dbt compile again, now the compiled version of intermediate what is that, intermediate order matrices should be changed automatically. Oh, not this one, should be this one. So that will be changed. There you go. So that will be changed automatically, the logic. So whatever refers to that macro, the logic will be automatically changed when we change that macro, this one. That is how macros work. I think now you got the macros concept, right? With that, we're done with this lab, which means we're also done with this module, the entire module. Let's head to the next one. And for our next module, we have module 8, which is sources, seeds, and snapshots. This is where we know how we use sources of to connect to external tables or data, And then we'll know more about seeds and snapshots and how we use that for to implement SCD2, slowly changing dimensions. To begin with, this conceptual architecture, and here it says external systems, raw data, sources, staging models, and marts. So we get the data from external systems as sources of and govern declarations, and we get the external systems data into staging models, and then it is transferred to marts. That's our part one, which is knowing about sources and external table governance. So basically, sources define where raw data lives, what schema it belongs to, what table exists, freshness expectations, ingestion level tests. All right. So sources are declarations, not transformations. They mark the official entry point in the DAG. That is what here. So we source the data from an external table, right? When we source it, we have to create a YAML file with the name that we define where we get the source to, and we define the source in a YAML file in this format. We say sources and the name of the database and the schema where the data is at, and the table's name and the names of the tables that we need to we are sourcing from. That is how we have to create the source.yml. We define the source.yml, and if we are sourcing that in a file that is inside staging folder, we have to define the sources.yml inside staging. And then referencing that source should be like this way. We select whatever we want from that source, and then we have to say from. We use this expression blocks to say source of whatever the tables that we are trying to import. Here, this example says, this example is sourcing two tables, raw and orders. That is how it goes. And while we source it, we can also run tests with the sourcing data, because that is a best practice. Imagine you're working with a real system and you're sourcing the data from an external source. And if you're not sure about a few things in that table, and you think that table has some stuff that you don't want, and you want to test if that table actually has that stuff, to test it, you can add test at the source level. So when we try to source the data or import the data from that source, before importing the data, actually it checks for that particular test that you define. There are a few predefined tests, which includes adding this part to the source YAML file, which includes test hyphen, and we check if there is any null values by this. So we make sure there are no null values by using not null, and we make sure every record is unique and there are no duplicates in this way. And then we run docker compose run and dvd test, and we select the source that we are trying to test. Or we can just say dvd test and it automatically tests everything. So just to make sure the ingestion integrity of the data. And also we can check the freshness monitoring. We can check the freshness of that sourcing data by using, if that particular the data that we're sourcing has a column something like updated it, which means a column that is updated. And we check the freshness by checking all the records and seeing if any of the records have the freshness that is, any of the record has passed 12 hours without any new records, which means the data is outdated. So we can do that as well using this format. We can say freshness and worn after, and whatever we define here. So if that particular time span is extended and the data is old, we just get warning because this is worn after and there is error of the after. So, and that checks if the data is older than 24 hours, and if it is, that triggers an error. This triggers a warning, but it still executes or stores the data, whereas this triggers an error and it stops. But the sourcing data has to have a column, something like this. It shouldn't exactly be the name, but we can define that particular column as loaded at field to check the time, so we can evaluate the freshness of it. And then when we run docker compose run dbt source freshness, it actually checks the freshness of that source, and if it is fresh, it passes the test. If it is older than 12 hours, it warns. If it is older than 24, it triggers an error and it stops. So these are the methods that we can use while testing the source. And then there you go. So this actually the flow that we just talked about. So it picks up the max of updated at that field that we defined and compared to the system time, the actual system time, and whatever the hours that we define here, we can define it with hours, minutes, or seconds too. So it depends on the measurement. And here we measured it with 12 and period as hours, so it is 12 hours. Now we are headed to the lab. Let's get to that. For the lab, we don't have an external data source, right? We don't have a table created already. So the first step, we are going to create a table basically in the same database and source the data from that table. So we are going to source the data from that table as an external table. So to create a table, we are going to access the warehouse again, the data warehouse, using this command. And here we're going to create a new schema because I don't want to contaminate the schema, the developer schema or the production schema. So I'm going to say create schema. If not exist, I'm going to name the schema as raw and a semicolon at the end to end the transaction. And I'm going to run that. I spelled I spelled it wrong. Okay. Let me try that again. Create schema. If not exist, and name it raw. There you go. Now we created the schema. Now we're going to create a table inside that schema that we created. Create table, say raw dot, I'm going to name the table as orders, then enter. The transaction will not end. Even if you click enter without a semicolon, the transaction will not end until you actually hit a semicolon and then enter. That is the only time the transaction ends, and if the query is valid, it will get executed, or else it will pop an error. That's how it works. Now we haven't ended that query with a semicolon, so it still continues. Now I'm going to type the next line, the continuation in the next line, as order ID as integer, and amount as numeric, updated at as timestamp, and now I'm going to end the transaction with a parenthesis to close the columns, to close the table columns. Now we are going to create 3 columns in this table, and to end the transaction we use semicolon at the end. Now if we enter, this will create a table, but because I spelled it wrong again, that triggered an error where I spelled the create as wrong. Now that's perfect. And then I'm going to copy paste the rest of the query again. Now that is perfect. Now we created a table. So now I'm going to insert a few columns, a few rows into this table just to make it look like an actual table and not an empty table. To insert data, I'm going to say insert into raw dot orders and say values and enter. I'm gonna enter these rows in separate lines, so that is much more readable. And for the first row, I'm going to type in 100 and now off, and this now off will return the current timestamp. And for the second row, 200 and now off again. And end this transaction with a semicolon at the end. Just 2 columns are just fine. So I'm going to, 2 rows are fine, just to create a table. So inserted 2 rows into the table that we created. Let's just make sure by selecting everything in that table that we just created. Select all from and end with a semicolon. There you go. Now we have everything ready. Okay, we have the external table ready for our lab. The next step is, oh, by the way, exit this warehouse by typing in \Q again. Okay. Now head to staging. Let me collapse the target and yeah, head to staging folder and then create a new file and name it sources.yml. Here we're going to define the source. We're going to connect the source using this file. So to do that, let's say version sources, name as raw, schema as raw, and then tables, and I'm going to select the table that we just created, which is orders, and the columns include the names, order ID. Now I'm going to define a few tests, the basic ones. So I'm going to select tests and say not null. So it tests that every column is not, every row is not null and unique as well. Perfect. Now save that. And next, create a new file in staging again and name it. Now, instead, we're just going to use the same file that we created, stg orders. Instead of using these values and creating a table using these values, I'm going to source these values from the source that we just defined. So I'm going to take this whole thing down and then say select everything and from and define the and connect, refer to the source that we defined, which is source of raw orders. That's it. Save this. Now here, we're referring to the source which is named as raw, right? Right here. And we're selecting orders, which is the table name, orders. Now let's run this model and see if it works. Open PowerShell and we run dbt run. Like that. Okay, we did got a few errors. Let me check that. Okay, now the problem is with the formatting of this YML file. I thought that will be taken care of by VS Code by itself, but no. Here, there should be a space in between the hyphen and the name here, and also should be aligned with that, and also this one as well. Same way, this should be like that, and a tab space for this one too, a tab space, and for this one too. I think this is perfect. This is formatted the right way. Now let's run that again. dbt run. So we got an error again. What is it? Invalid source config given in models source raw schema. It's the format again. There should be a space in between these two. Okay. I hope this time it works. Run it. Okay. Now it worked. But the error here is actually, what is it? Okay, amount does not exist. Tax total amount does not exist. Okay. So the error is not with the source. The error is with the facts sales.sql, the marts one. And we got that error because in the previous lab, I think it's not the previous lab, the one before it, where we did some modifications to the intermediate model. And because, like I said, the fact sales is directly, is referencing that intermediate model, this will definitely fail. And that's what happened. But we will fix it later. But for now, we're going to ignore it and see if the actual STG orders is executed. Right here it says start SQL view STG orders, and it says okay, created SQL model dev underscore schema STG orders. Create view is successful, so which means our data is actually retrieved from the source. And we can run dbt test on this source as well. And to run that, what we can do here is we can say instead of dbt run, we can say dbt test and only select source raw dot orders, and now run this command. Now this checks this tests the tests that are mentioned in the source, which include checking if the rows are not null and if they are unique. And both the tests passed because we only wrote 2 rows in it and we did it manually, and both of them have no null values, and also both of them are unique from each other. So both the tests are passed. But these are we actually run dbt test. And for dbt freshness, we haven't entered anything or defined anything for dbt freshness here, but we can by writing something like this, right? Okay. Let's try to use this here. Oh, there you go. Yeah, we do have our source does have a column named updated it, right? So we can actually check the freshness of it. And for the period, I'm gonna leave it the same way and say count 12 and period hours the same way. So our data is just made like 10 minutes ago. The updated at time should be 10 minutes ago. So this should also pass the freshness test. Is that correct? Now check that one last time. Okay, So that is correct. Now to check the freshness, we just have to say dbt source freshness and copy this command and paste it here and run it. There you go. Now the freshness test is also successful, because like I said, we just created those, and we use now off for those columns, which means the present time, and we created that 10 minutes ago, so the data is fresh. That's why everything passed perfectly. That is done. We're done with the first lab. Now heading back. So we're done with this lab 1. We head to part 2, which is seeds. Well, we already know seeds load version controlled CSV data into PostgreSQL via dbt. So we save a CSV file in under our seeds folder, and then when we run dbt seed, that CSV file will be saved as a table in the database. That's what happened before, right? Now what we're going to do is we're going to see if we can how we can refer to a seed instead of referring to a table. Until now, we see how we can refer to another model, right? We referred from here. We referred to another model using RAF of STG orders, and we refer to the same way we refer to the models using RAF of and using the expression blocks of Jinja template. Now we're going to see how to refer to a seed that is saved. So to refer to the seed, what we're going to do is going to follow this lab. We already have the CSV in the seed, and we created this by running dbt seed already, so we don't have to do that. Now I'm going to create a new model named stg seed test.sql, and then use this query there to test it. So let's test it. Under staging, new file, say seed underscore test. Now stg underscore seed underscore test dot SQL. Here we're going to write select all, say from, and we use ref reference of countries. That is the seed name, countries, right? So we're going to refer to that. I think you got it, right? So we already have this countries.csv under seeds folder. We are going to refer to that seed using ref of countries. Save it. And execute dbt run. I'm going to unselect this, don't need that, and then say dbt run instead. Copy that, run that command. There you go. Where is, okay, there you go, stg underscore seed underscore test. It did actually create a view by selecting all the data in that particular seed. So let's make sure all the data is actually selected by accessing the warehouse and selecting all from this view, and there you go. Now we actually selected all the data that is in the seed into a model or into a .sql file and worked with it. That's how connecting to seeds work. Now we're done with the lab 2 as well. Okay, now head to the part 3, which is snapshots and slowly changing dimensions. Talking about snapshots and slowly changing dimensions, like I said, we create a snapshot to save, if there is, to save the row based changes. If there is any change, will, or if you expect the rows, if you expect the rows in a table are going to change, you can use snapshots. So it saves the row based changes and saves the old ones as well as the new ones in a format that actually helps slowly changing dimensions, helps us to implement slowly changing dimensions. So when we create a snapshot, we create it in this way. We create a snapshot and save that under snapshots folder, by the way. And it looks something like this. It says snapshot, and we name the snapshot order snapshot. In here, in this example, it says orders snapshot. And the configuration for the snapshot, it's configured as target schema, snapshots. So here we are referring to, it refers to a schema named snapshots. Basically, in real world, we don't use the same schema that we are working, like the developer schema or development schema or production schema. We don't use any of the schema. We isolate by creating a new schema just for the snapshots, because snapshots take a lot of memory, because it saves the past values of every row and the future values as well. So it takes a lot of memory. So it needs a dedicated schema for itself. So that's why we use a separate schema. And here we define the unique key and strategy. There are two types of strategies. One is timestamp. So it checks the timestamp and see if there is any updated rows. If there is any, in this strategy, this strategy is about checking the timestamp to see if there is any updated rows. If there is, it saves those new records and mark the old records as inactive. That's how it works. And the same way, there is another strategy, so which is, I think it is check strategy. It should be somewhere here, the example. Okay, so there is another strategy which is named as check strategy. Instead of we using time strategy, we use check strategy, and that check strategy is something different from this, where it checks a column that we define. Let's say if I define a column named amount, it checks for that column. If that column is updated in that in any of the row, it saves that latest value and marks the old value as inactive and marks this as active. That's how these strategies work. So there is timestamp and there is check strategy as well. Okay, we know that. So this here, when we create a snapshot, these are the fields that dbtr is going to create automatically. So snapshot table metadata, dbt automatically manages dbt valid from, dbt valid to, dbt scd id, dbt updated at. There you go. Do not manually modify this. We don't actually manually need to modify that. dbt actually manages these things when we create a snapshot. If you don't know about slowly changing dimensions or anything like that, I would highly recommend to refer to a project. I think that is about banking modern data stack project that I made a video a few months ago. So check that out. In that project, we actually implement slowly changing dimensions type 2, dealing with that. And yeah, that will help you understand it even better. Okay, now we have a lab here. Let's do that. I'm going to open VS Code, and here I'm going to create a snapshot file. Under snapshots, order snapshot.sql, run it, and inside flower brackets, percentage, snapshot, and name the snapshot as orders underscore snapshot. And configure the snapshot. Configure it. We say config target schema. Now for this, for the snapshots, we're going to create a new schema separately for that. So I'm going to name it snapshots. We haven't created the snapshot in the warehouse, but this will automatically create a snapshot for us. And I'm going to use check strategy here to check for the updated rows. And the column to check for the updated rows is amount. Say select order ID, amount, from ref of STG orders. There you go. Now save this. Oh, I forgot to end the snapshot with a flower bracket. Percentage and snapshot. Perfect. Now we have the snapshot created. I mean, we have the definition of it. Now to create a snapshot, we have to run dbt snapshot. So instead of dbt run, here we run dbt snapshot. dbt snapshot. Now copy that, paste it in the command main. Okay. Right now I'm inside the warehouse. I have to exit that first. Now I'm going to paste the command and run it. There you go. Now the snapshot is created. Says okay, snapshot at snapshots, order snapshot, and select it 2. So selected 2 records. Okay, that's good. Now we're going to modify something in the upstream, which is STG orders, because this is referencing to STG orders. So we're going to modify something in that upstream. To modify, we head to the warehouse again, And to get access to the warehouse, we're going to run that command again. Now we're inside the warehouse. Now we modify something inside the table that is named STG orders. To modify, we say update raw.orders, say set amount equals 150, say where order ID equals 1. Before this, the table used to have amount as 100 for the order ID 1, but now we are updating that table by updating the record and setting the amount as 150 where the order ID is 1. So we're actually modifying it. Now it says updated. And the next step will be quitting the warehouse again. Now running dbt run command, because we have to update the STG orders model for that, right? So we say dbt run again to update that model. Dbt run. And then we have to run the dbt snapshot again. Dbt snapshot. Now this will capture the snapshot. Now it says insert 1. So it inserted a record, which will be the new record that just got updated. So when we connect to the database again, the warehouse again. Okay. Now here, if you run select all from orders.order snapshot, and there you go. Let me make it clear for you to read it. And here we can see order ID, which is this, and we have one row for order ID 2, but for order ID 1 we have 2 rows because the amount is updated once. So this is the old row, which where the order ID 1 is assigned with the amount as 100, and this is the SCD ID dbt updated at, and dbt valid from dbt valid to. And then this is the latest row that we just updated, and we updated from 100 to 150, and this is the updated row. And if you take a look at the columns, except this column, the rest of the two columns, the dbt valid 2 is empty, and that is because this is the only old record that exists in this table right now, and this is expired record, so this is not active, so it has valid from and valid to as well. So it is basically like manufacturing date and the expiration date, and now this row is expired and this row just manufactured when this row is expired. So this will be same as this, because at that time this got inactive and this got active. That's how snapshots work. By using these snapshots, we can actually implement slowly changing dimensions. Now we're done with that. Now let's exit. Okay. And say Q. That is done. So with that, we're done with this module. So that's our last lab, I think. Yeah, that is our last lab. With that, we're done with this module. Now let's head to the next one, which will be phase 3, module 9. And for our next module, we have module 9, schema and custom testing, which belongs to the phase 3, testing and quality enforcement. Basically, this phase have two modules, okay? And the first module is this. This module is primarily focused on custom testing. Until now, we know how we can use test, we can configure test, but all those tests that we saw until now are the predefined ones, right? Like, let me close all this. Like this one, we use the predefined test, the not null and unique. And in this module, we're going to see how we can actually define a custom test, define custom testings and run them, run the tests. Okay, and this is the conceptual diagram we have here, which shows the test execution architecture, the model, source, seeds. Basically, the test can be applied on models, sources, or seeds as well. We already applied the test for the sources. In this module, we also see how we can apply tests for the models as well. Okay, and now the next step will be tests. We can create test, the custom test, in two ways. Using the first way is using YAML files, which are generic tests, and the second way is by using .sql files, which are saved under test folder, and they are basically singular tests. So they only have they can have multiple .sql files, and they all belongs to one folder, which is tests. So these are two types of two ways to define tests. And after that, after we define all the tests, we run dbd test command, which compiles and then executes in the warehouse. And if the test returns the 0 rows, it passes. If the test return anything more than 0 rows, the tests fail. When I say that, what I mean is these tests actually filters out the rows that we don't want. So we customize these tests in the way so they return the rows that we don't want. If there is any rows that we don't actually want, that will return any rows more than 0, right? And if that returns any rows more than 0, that will fail. The test will fail. If that returns 0 rows, then it will pass. It might be confusing to understand theoretically, but when we run practical part in the lab, you can actually see what happens and how we actually customize these tests by ourselves and run it. Firstly, in the first part, we talk about generic test first, which is nothing but customizing tests in the YAML files. And they both, the generic test and the singular test, protects two different constraints. This generic test protects, this generic test answers, can this column be null, or values unique, or foreign keys valid, or values restricted to an allowed set. They enforce structural integrity. So basically the generic test enforces structural integrity. This is the main point. So this one enforces structural integrity, and the singular test enforces I think it is logical integrity. Oh, business constraint integrity. So this enforces business constraint integrity, and generic test enforces structural integrity. And these are the built-in generic tests. We already used unique and null, right? We already used unique and null. And there is also accepted values, where we can actually define the values that are accepted, and anything in that column. So anything else, anything outside the accepted values are coming into the row, will fail the test. That is what it says. So when we try to test, when we define a generic test with an accepted set of accepted values, the column matches whitelist, and there is relationships, parent key integrity. So we have all this. This is an example of how we actually write the test. We already used these built-in tests already, so we know how to use it, right? Because we use not null and unique. And there you go. So these are, we can actually use accepted values test. So we can say test accepted values, and we can also define the values as as a list of accepted values for that particular column that we select. And anything other than pending, shipped, or cancelled is getting into that column will fail the test. And this is the relationships example, where we can actually make sure the relational integrity, make sure to enforce the referential integrity. We say test, and then we say relationships, and say to reference of STG customers and field customer ID. And that way we actually see the referential relational integrity between the tables or the models. Now we head to the lab 1, which will be the structural enforcement, where we write a .yml file just for the tests and run it. Well, we already ran these generic built-in tests on a source, but here in this lab we are going to run those tests, the same tests basically, on an actual model, which is STG orders. So let's do that. And for that, we create a new .yml file under staging. It's a new file. Say stg orders.yml. stg orders.yml. Here we say version s2 models. We have to give a space after the hyphen and say name. STG orders. Columns. And select the columns that are in the STG orders, which include order ID and amount. name, order ID, and tests to run. I cannot actually spell tests. I don't know why. It comes like tests. I don't know why. I'm trying my best to pronounce it. And say the first test as not null. Not null. The second one as unique. We should not forget the space between the hyphen and the actual text. Then name again and name the second column, which is amount. Tests as not null. Well, amount doesn't need to be unique, so I'm just going to leave it like that. So this is how we can actually define generic tests in a .yml file. We already talked about this when we wrote this source.yml where we defined a source and ran tests on it. But here, if we want to run these tests on a model, this is how we do it, the generic tests. I saved it. Now I'm going to run dbt test. Instead of dbt run or dbt snapshot, we have to run dbt test to check all the tests. Copy that command, run it. Okay, we have something here. Oh, it is a parsing error, so I did messed up with the format again. Okay, I think it should be this one. There should be a space after the hyphen. I forgot that. Okay. I think now it is fixed. There you go. So it checks everything, checks all the not nulls and also the uniqueness of the records. But here we see a lot of tests because it also included the source test. When we said dbt test, it also tested this source tests as well, and that's why we got a lot of tests happened here, and all of them are successful, or all of them passed. That is good. So we're done with the lab 1. Moving on to the part 2, which is singular tests, where, like we already talked, generic tests are about protecting the structure of it, and the singular tests are about protecting the correctness. Generic tests protects structure and singular tests protect correctness. They are standalone SQL files that are saved under tests folder. We already talked about it. They're just a .sql files that are saved under tests folder. The same logic applies here as well. When we run dbt test, it tests all the files that are saved under tests, and if those tests return any value, that will fail. If that doesn't return any value, that will pass. So classic example, you know what? Let's try to head to the lab so we know what we're doing. Okay. For this one, we're going to create a test and save it under because this is a singular test, is it? Yeah, because it is a singular test, we have to save the test under test folder as a .sql file and name the file as test underscore amount .sql and say select all. We write these tests just like we write an SQL query. Let me capitalize them just for the readability. From the reference of fact sales where revenue is less than 100. Save it. Save that. Now we have to run dbt run first. So let's run that. I think now I have to fix that fact sales model because we modified intermediate order matrices. We have to now fix the fact sales so it gets yielded with that new update that we just made. So I'm going to do that and be back in a second. I don't want to waste your time by watching me modifying that file. So I'm going to make it. I'm going to make it ready and be back in a second. Okay, this is the updated fact sales.sql marts table that I just updated. The model, not the table, by the way. The model that I just updated. But because incremental table will not replace the old table and create a new one, and these are my incremental table, by the way. So because it doesn't replace the table, if I just run dbt run again, it still shows the same error and saying amount does not exist. So to actually drop it and create a new table, we have to add something like this. After dbt run, we have to say hyphen hyphen and say full hyphen refresh. So it refreshes everything. It does full refresh. It replaces and rebuilds everything from the scratch. So I'm going to do that and run it. Now it will build everything from the scratch, which means it will be successful. We only have to run it once just to drop that incremental table and create a new one, or rebuild a new one. Now it is rebuilt. Okay, now we are done with that. Now we run the tests using dbt test instead. Okay, everything is passed, but I want to find the test that I just created now. It's definitely not the not null. The test that I just created is testamount.sql. Okay. Okay, now there it is. This is the test that we just defined, test amount. And it is passed because there are no rows which has the amount value or the revenue value less than 100 because everything is greater than 100. What I'm going to do is I'm going to modify this into 200. Now this will trigger an error. Okay, so to run that, I'm going to run the dbt test again. And there you go. Now the test amount failed because it doesn't, it returns one record. I think now you got the point about this conceptual flowchart, right? Where, there you go. So it says if 0 rows or if it generates 0 rows, it will pass, or if it generates anything more than 0 rows, it will fail. Now I think you got the point here. And the point is, when I say less than 100, there are 0 rows that are generated by this test, this particular query, right? Because there are no rows with revenue less than 100. Whereas now when I say 200, there is one row which has the revenue as less than 200. And that is why the output will be one row, which means the test will fail. And that is why the test failed now, like that. So it says got one result. So there is one row that doesn't satisfy the condition. Okay, I think now we know how these two custom testing methods work, right? The generic test and the singular test. We also know what each does. Generic test protects the structure and the singular test protects the correctness. Now let's head to the next module. And for our next module, which is module 10, we have test execution strategy and CI enforcement. Now, we already talked about CI, continuous integration enforcement, where we actually work with a separate branch by creating a separate branch which is isolated from the main branch, and then when we integrate the changes that we want to integrate with the main one, there are a few tests in the production environment where there will be a few tests to run before we integrate that branch changes into the main one, right? We're going to talk about that in this module. We have a conceptual diagram here, and which has a few basic tests that most of the deployment platforms have, deployment environments follow, which includes, we basically run dbt source freshness to see the source freshness and make sure the source is not outdated. And we use dbt run to check everything runs fine without any errors. And we also run dbt test to run all the tests that are defined in that project and check if any of those tests return any value. If any of these tests returns any value or any non-zero value, the integration will be blocked. If that doesn't generate any value, that will be deployed to the actual main branch. That is what this flow says. So it says, is it non-zero exit code? So it actually says how many of these tests are failed. If there are multiple, it says 2, or 1 if it is single fail. So it should be 0. So the non-exit, the exit code should be 0. If there is non-zero exit code, if it is yes, it is blocked, the deployment is blocked. If that is actually not a non-zero exit code, which means a zero exit code, and that will be deployed. That will be deployed. So the exit code should be 0, which means there are no fails in the tests. Now our first part is test execution strategy. We already talked about how these operations are done, right? To be more clear or to be more precise, I'm going to show you how this actually works. Let me create a new slide right here, new slide, an empty one. Let's say we have our project repository, which will be the main branch, right? So let's say we have the project repository, and this is the main branch. Okay, this is the main branch. And now we created a new branch for for the development environment. So you created a new branch to work on that project. Okay, there is a new branch. Let's say new branch. So what a new branch is exactly is you just clone the main branch, but whatever the changes that you do in this branch, the new branch will not affect the main, but you still have the cloned version of main branch. So you can work isolated. You can work isolated from the main branch. So whatever you do, you shouldn't worry about contaminating the main branch. So you can just go for it. And if you actually think the changes that you do in the new branch are worth integrating with the main branch, then as a developer who is working on this branch, let's say you are a developer, okay? So you are a developer, okay? You are a developer working on this branch, and you think the changes that you do in this branch are worth integrating to the main branch. You as a developer does a pull request, sends a pull request, okay? And if that pull request is actually approved, then the CI implementation will happen, which means a CI implementation can be configured by ourselves, and the usual configuration will be the way that I talked before. So the usual CI configuration be running a few bunch of commands, which includes basically the dbt source freshness, dbt test, and dbt test. Dbt source freshness, dbt run, and dbt tests. These three are the commands that we run before we integrate these new changes into the main branch. I think now you got the concept exactly. So that is how this branching works in Git. Okay, so when you as a developer do a pull request and CI and the pull request got approved, and these are the basic commands that are run in the CI, the continuous integration layer, before we integrate those changes that are done in the new branch into the main. And check if any of these tests or fail, that new branch fails any of these tests, that will not be integrated to the main branch. If they're all passed, that is the only time it gets integrated to the main branch. That is how the repository, the CI works. And in few cases, when you're working with a huge amount of data or a big project where it has a lot of models or a lot of tags created when you run dbt run, you don't want to test all of that when you want to integrate something into the main branch. You don't want to test all the files, all the models that are in that project, right? You don't want to, because that doesn't make sense. I mean, let's say the changes that you made are only at half of the project layer, and you want to integrate it with the main branch. You don't need to run everything from the beginning, because these are the commands that are actually used, right? dbt source freshness, dbt run, dbt test. And the change that you made doesn't have anything to do with few of the sources. Still, when you run this command, all those unused or unchanged sources will also get checked for the freshness, which doesn't make any sense because we are just wasting the time and the computational power there. And the same applies to the dbt run. If we said dbt run, it executes the whole project and not just the part that we actually need. So what if I say, instead of testing everything with this simple command dbt run, we can add something right next to it, so it only runs the part that we need and not everything. Something like this: development strategy, fast feedback, focus on changed model, downstream impact, quick iteration. Let's say you changed the model in the new branch. Okay, you changed a model in the new branch, and you only want to see if that branch made any changes or did something wrong to the rest of the project. To see that, you don't have to run the whole project again using dbt run, right? What you have to do is you can run tests on that model and the downstream of that model, and that's it, because the downstream is only the are only the models that are affected by this model, not upstream. Anything upstream is not affected by this model. Does that make sense? And that's why we can run something like this. So we can say dbt run and select, and the model name, we already used this. I think we already used this in some of in one of the labs, I think, where we say dbt run select, and let's say if we change the intermediate stage model, we can actually define that model name here and select and say intermediate order matrices here and say plus. So only the intermediate order matrices and the downstream, which is the fact cells and all the stuff, will be re-executed, or tests will be run on those models, and the rest of the upstream will be left alone. Nothing happens to that. By that way, we can actually save time and make the process quick. This is an important topic you have to know when you work, and because this is so helpful when you work with a system that is so big, which has a lot of models or a lot of data in it, basically. So this is the best way to do that instead of running the whole model. That is one way, and there is another way. Oh, by the way, these execution strategies are known as layered execution strategies, and this we just talked about is development strategy, the first strategy, and there is another strategy which is named as CI strategy, modified graph only. What we do here is, instead of running the same way, instead of running the whole project again using dbt run, dbt test, what we do here is we select the modified part. In the development strategy, we select the model name by ourselves, but here we only select the modified part and not the exact model that we modified. In few cases, we don't know what we modified. We don't know what part of the stream we modified, or what the topmost node we modified, right? In that case, what we can do is we can just use CI strategy, where we run all the tests on the modified parts alone. And the way we do that is we can just when we compile, when we run dbt compile, the whole plan in that DAG, in that particular project, will be created as a DAG, right? Created as a DAG and saved. And that DAG will be saved in manifest.json. You remember when we talked about that? So when we run dbt compile or dbt run, when the whole project is compiled, the DAG that is created from that will be saved as a metadata in manifest.json, right? So what we're going to do is we save that particular state. We save that manifest.json in another or in a different folder, which will be our current state, and then we start working. We start doing changes to the project. So whenever we run dbt run or dbt compile, only the new manifest.json that is saved under targets will be modified, and not the manifest.json that we saved somewhere else. Okay, so after we did a lot of changes, you know what, I'm going to draw that as well. These concepts are quite complex to just talk about, so I want to show you how it works with a visual as well. Okay, what we just talked. So let's say this is our project. It has a lot of models, a lot of seeds and everything. Okay, and it has a folder name target, right? And that folder consists of a file manifest.json. Okay, and this, when we define all the models and everything in the project and we run dbt compile, everything gets compiled, and the DAG that gets created from the project will be saved in manifest.json. So the old manifest.json will be overwritten with the new manifest.json, with a new DAG. So what we are going to do is, with this current state, we're going to save this manifest.json somewhere else in a folder. Let's say I'm going to name the folder as artifacts, and I saved this file manifest.json in that location. Okay, now if I do any modifications, I do modifications to this. Oh, that is horrible. So I do modifications to this. Okay, and now I run dbt compile again. Now what happens? The new manifest will be replaced with the old manifest.json, right? But it only be replaced under the target folder, and it will not take care of, it will not change or touch this manifest.json. So only this manifest.json will be replaced, which means the state will be updated in that spot. So no matter how many times we run the compile, that particular manifest.json will be updated. But still, the old state that we started before even doing all these modifications will be still saved here, right? So what we are going to do is, we're going to point to this manifest.json, artifacts manifest.json, and run dbt tests and say modified plus. So what it does is, it compares the old manifest.json, which is this one, with the latest one, and only runs the tests on the modified parts of the project. And that is how this works. I tried my best to explain this, but I am going to demonstrate this lab as well that we just talked about, saving the manifest somewhere else and then doing modifications. We do that, okay? But that is how visually it is shown. So we use this. So it says state modified plus, everything goes fine. And here it says state previous. And when it says state, here we say artifact slash manifest.json, because we saved the manifest.json under artifacts folder. So we point to that old manifest.json. And that is our second strategy, which is CI strategy. And there is another strategy, which is production strategy, which is nothing but executing, which is the full enforcement. It just runs for the entire DAG, entire project. That's the regular one. Okay, we know about that. Now, talking about CI simulation. Don't you worry, we will do that, the modified. This CI strategy. We will do the lab on this CI strategy in this part, okay? Now, our next part, we have CI simulation and state-based enforcement. So like I said, after the changes are confirmed and the developer wants to implement those changes, integrate those changes into the main, developer will start a pull request, right? PR, developer pull request. And if that is approved, the CI will be triggered. And after CI is triggered, it goes through all the commands that we define. And if we define all these, this will be executed. But now we're going to see how we can actually execute those tests on only the part that is just modified and not everything. That is what we're going to do in this lab. Okay, to begin with, we're going to first make sure the manifest.json have the current state saved. Okay, so we are going to run dbt compile. I know we already run dbt run a lot of times, but still, just to make sure everything is up to date in the manifest.json, we're going to run dbt compile again. Run it. This will update the manifest.json now with everything up to date. Now, after that, I'm going to create a new folder in the project itself and name it, like I said, I'm going to name it artifacts. Okay. And then copy this manifest.json into artifacts here, paste it, so we have it there. Now, dbt can't actually access artifacts. Not access. dbt doesn't care about this folder at all. So whatever we do, it will not update this manifest.json. It only updates this one. Okay. So we close everything. All right. Now I'm going to open the intermediate order matrices here, and I'm going to change something. Let's say I'm going to change this one from 0.6 to 0.5. Well, that is still a change, which will change the manifest.json. Okay, so that is still a change. Now I'm going to save that. And then run dbt compile or dbt run. Both works. I'm going to run dbt run just to see if there is any errors as well. So I'm going to say dbt run. So I ran everything, which also includes compiling them. So when it's compiled, the manifest.json will be updated. So that will be updated now. Everything works fine. But Now we can actually use our old state to run the test only on the updated part of the DAG. So to do that, what we can do is we say docker my bad. So what we can do is we can just say dbt run again. I'm going to run dbt run again, but only on the modified part. So dbt run, say select state modified and say plus and type plus next to the modified, so it only executes the downstream of it. Modified plus, and now define the state, which is the previous state, and that is saved as artifacts folder. Is that correct? Did I spell it right? Artifacts. I think I did. Okay. So that is where we saved our old state manifest.json. And the rest is the same. Okay, paste it here. Now run this command. Now see what happens. Okay. If you take a close look at this one, it haven't executed everything. It only executed that is modified, which is int orders matrices. We modified that, remember, and also the downstream of it. Everything that is dependent on that particular model alone and nothing else. Before, when we run the actual dbt run without anything, it run everything, every model that is available in the project or in the DAG. But here, it only ran the modified part and the downstream of that modified model. So not the module, the modified model, which includes int order matrices and fact sales, which is the downstream of intermediate order matrices. And that's how it works. In the same way we use dbt run, we can also do dbt tests in the same way. Okay, instead of dbt run, here we say, let me just copy this. Let me paste it in the next line and then modify this to test. So this is, sorry, this will run dbt test only on the modified part. And there you go. Before, when we run dbt test, let me just run the dbt test without the modified and see what actually happens, and we compare both of them. Okay, so this one, and here I'm just running dbt test and see how many tests get executed. You see that there are these many tests that are executed, but when I say modified, it only executes the tests that are downstream of that modified part, which also includes, let me see, so it only executed test amount, right? The singular test that we define, which is under test amount, and that is the test that is happened on fact sales, which is under marts, and which is the downstream of intermediate order matrices, and that is why that test alone got executed and nothing else is executed. And that's how we can actually do it. Instead of running the test throughout the DAG or throughout the project, we can do that. Now I think you got it. So this stuff is basically primarily focused on the CI integration, I mean continuous integration CI part of managing a project. But this might sound simple, but it is so important when you work with a big project that where you implement DBT and you actually use Git to manage your repository. This is important. Now with that, we're done with this lab, which means we're also done with this module, module 10. Now let's head to the next one. Now heading to our next module, which is module 11, where we talk about YAML specs and documentation side, which belongs to the phase 4, documentation and observability. So this whole phase is about documentation of the models. I mean, not just the models, of everything, basically. Now, okay, this module turns your DAG into an explainable system. Instead of just a DAG, we actually assign documentation for all the projects, so it is explainable. So what we basically do is we create documentations for any of the models or sources or seeds or snapshots, just to describe what that particular entity is doing, or inside the, and also we can also describe the components that are inside, the components or the elements inside those entities. If it is a model, we define what that model does and what that particular column does, and what, you know, it's basically about describing the stuff. And this is the flow. We say YAML, we create a YAML file for more, it can be for model sources, seeds, or snapshots, any of them. And then we use dbt parse, and that will create manifest.json. And when we run dbt docs generate, it generates all the documentations, which includes catalog.json plus index.html. So index.html is basically for the dynamic side that gets created when we create a document. When I say dynamic web site, it just creates a HTML file in the project repository. But we can use that HTML file to actually see that in a web view, in a web UI. So I will also demonstrate how to do that as well later. So that is how it works. And then interactive documentation site. So from this index.html HTML code, we can actually create an interactive documentation site where we can see all the, or where we can actually monitor the whole project and all the models or seeds or snapshots, everything in that. Now, talking about the first part, YAML documentation specifications, the purpose is to basically document everything. That's it. Just to make it more understandable for anyone. Even for us, if we work with a big project and we work with a lot of models, if we write that model, we are familiar with that model and we can remember what that model contains, like just like for a few days. But after a few days, you will forget what that model has, right? And that is why it is always a best practice to document everything. So you explain all the columns that are in the model, what it creates, and describe them. So even when you see that model again after a few years, even, you can identify them by the descriptions, and it makes you your life a lot easier to understand it, right? That's how it works. And here's the thing. Docs live next to the models. So if you are creating a documentation for a particular model, the documentation lives right next to the model. Documentation evolves with logic. Okay, if docs live elsewhere, they rot. So if the documentations are saved anywhere else other than next to the model that they are describing, it doesn't make any sense. They are rot. Okay. So this is the basic structure. So if you are creating documentation for stage STG orders.yml. So STG orders, if you're creating a documentation for STG orders, we create it this way. We say STG orders.yml, and then we define everything. We define the model name, which is STG orders. About. And describe the whole model. It says cleaned order data standardized from raw ingestion. And we also describe each column that model has. So when you describe in this way, even after years, when you come back and see this, you can actually see what you did, right? Not this YML file. No, I'm not talking about this YML file. We are going to use this YML file to actually create the documentation and then see those descriptions in an interactive UI. We're going to see later in the lab. Now, so that is how it works. And the main purpose of this documentation is, let's say, you might think, well, I will remember the columns that I create because I named those columns in the right way. But let's talk about a situation where you defined a column name as amount, but for you it is fine. But if someone else is working with you along with you and he sees this column amount, he might get confused. The questions that comes into his mind is it gross or net? The amount is gross or net? Or is a tax included in the amount? Is it currency? I mean the currency of the amount? And also, is it rounded or refunds included? All these questions come to their mind. And that is why we actually document it and write the descriptions for each of the columns. That is the main reason. And also, you can push these descriptions that you define in the YML file to the warehouse as well by just modifying the dbdproject.yml file and saying dbdproject and plus presses docs and say relation equals true, column equals true. This will push and executes this logic. It comments on every table, on every column that you defined, and assigns those comments to it. Now, first, let's execute. Let's go with our first lab here, which is this one. Now, you know what? I'm just going to copy paste this because it is so inefficient to run everything or to write everything right now. So I'm just going to copy paste every single line by explaining what we are doing here. Okay. So let's head to here. And the first step is to create facts_sales.yml. Right next, and that should stay right next to the factsales.sql under the mods folder. Right click. No, not the new folder. Right click, new file, and name it facts_sql.yml. This will be the documentation for that model, the fact sales model. And the version 2 and the model, copy paste that. So here we are saying we are defining the model and the name as fact sales because this is a documentation for that model, and we describe the model as fact table containing finalized sales matrices for reporting. That is the main description for the whole model. And now we copy the column part, which is this. Now this includes the description. So this includes the description of that column, that particular column order ID. It says unique identifier for sales transaction. That is perfect. And for the next column, we have revenue. And the description for that is net revenue excluding tax. So this is how we make the descriptions very clear. So when you see revenue, we don't know if it is excluding tax or including tax. And that is why we say in the description, we say net revenue excluding tax. So now we know it is a net revenue and not the revenue per day or something like that. So it is a net revenue. And it is excluding the tax and not, so the tax is not included. That is how descriptions work. And lastly, we have margin. And the description for this is profit margin ratio calculated as profit divided by revenue. We also say how this particular column is calculated or derived. It is derived by calculating profit divided by revenue. That is what we actually did in factsales.sql, right? We did, oh, we haven't done that here. We did that in intermediate order matrices. But the margin column is, that is how it is, the margin column is derived. Now we have descriptions for all the columns and the model as well. The next part is generate artifacts. Sorry, generate artifacts, which means generating the documents using dbt docs, this command. Now let's run that by copying it. Paste it here. This will generate index.html. We haven't had this file before, so this will generate index.html and the catalog.json, right? There you go, catalog.json and index.html. So like I said, index.html is a static HTML code. So basically a website code that we cannot read unless we know HTML, which I don't. So I'm going to close that. So these are the documents that gets created. And oh, the manifest is also updated, by the way. That is updated, and the catalog.json is created, and index.html is created under targets folder. Now we have those folders, those files. Now the next one is to inspect manifest. Well, we cannot actually inspect manifest because that is not human readable. What we can do is, like I said, in few cases we can actually read manifest.json when we actually know what part to look at. So I'm going to look at, so I'm gonna open the whole file. We probably get stuck when we run something or when we try to find something here. So I'm going to hold Control and click F to find something. And here I'm going to say description. Perfect. Oh, that is too much. And we have to find the description we need. Or else what we can do here is Instead, I'm just going to, I missed it. Okay. Okay, I got it. Okay. I missed it again. Okay. I'm going to copy this part. All right. Now click Ctrl F, paste it here, and type something in that we already described, which is this. I'm going to include this in there. So now we are actually finding this description of our order ID. Okay, we go back here. Now try to find it. There you go. These are we can search the manifest.json, but it is hard because the file is so big. But we can actually do that in this way. And there you go. Now the name order ID is assigned with the description that we defined unique identifier for sales transaction. Well, like I said, this is not humanly readable. This is for the computer to read. So with these files, in the next lab, we're going to generate a UI, an interactive UI where we can actually read the descriptions. Now I'm going to close this. So the next part is documentation site generation. Like I said, we're going to generate a site. Okay, the conceptual diagram, project files, dbt pairs, manifest.json, it creates manifest.json, catalog.json. So manifest.json is a logical graph, which is the DAG. And catalog.json is a physical schema. And then when we say dbt docs generate, it creates index.html, which is the static site, which is HTML code. And we have to run something like this to actually initialize that web page, that UI in a web page, so we can access it. I'm searching for the lab. So right away we jump into the lab. We don't need to go through all the stuff, the theory. So we just jumped into here. Now it says, did we run dbt doc generate already? Yeah, we did run dbt docs generate. And the next step will be running this. This will actually initialize the website with the interactive UI where we can actually see the work that we did. Run that command. And the port that we initialize the UI is at 8080. Okay, so after running that, we have to go to that port. There you go. So this link, we have to go to this link and open it in any web browser. Run it. And that is how we actually created the website. We initialized the website with our project. It has everything. This is our project. It has the sources that we have, which is raw and dbt project. And the raw has orders. I think we created this for I don't know which module it is. We just created this. Okay, this is our actual project. Our project has macros, model, seed, snapshot, test. Everything, every single thing is listed here. You see that? In a UI, in an interactive UI. When you click on this, everything is described here. The code that you used, and the models and referenced models, and I mean referenced by. Okay. And the database also. The database is also in this UI. You can actually access the database, which is this is the database with the name dbt underscore warehouse, and these are the schemas that database has. dev schema, snapshots, and raw. We haven't created any schema for production yet because we haven't done anything. So that schema is not created. We created this for, not sure why. Yeah. We created that for sourcing the data. So we created this schema for sourcing the data and orders. Has everything, all the column names and the code that we use to create the, the table. And here's a snapshot schema, and here's the dev schema, which has a lot of tables and views created. And let's open this one. Okay, now this says, but wait, what example did we took? We took an example of fact sales. Now let's check that out. So let's open fact sales instead. Let's go to projects, models, and under marts, fact sales. And here, remember we defined the descriptions for all the columns, for a few of the columns, not the cost one, but for the rest of the columns. So we can actually see the description for all the columns that we defined. And here it says order ID, unique identifier for sales, transaction. And also at the beginning, we can actually see the description of the whole model. Fact table containing finalized sales matrices for reporting. This is the interactive way of us seeing the stuff instead of reading the manifest.json, which is humanly impossible. And it also shows referenced by. So this is referenced by one model, which is test amount, right? So let's see if it is actually, I think I created test amount somewhere, and I think I also deleted it, so I can't find it, I think. Okay, that's fine. But it also shows on what it depends on. And this model depends on this model. So okay, it is basically saying this reference. So it depends on that model in intermediate order matrices. So it shows that, and also the code that we wrote, the actual code that we wrote, everything in an interactive way. So this is how the documentation goes. We can actually see the database and the project, everything. But we can only see the descriptions of the columns for which we actually define the descriptions, and the rest doesn't have any. Let's check one last thing and leave. Just get out of this one and go to the next module. Here, so we see it doesn't have any model description. This model is not currently documented, so no documentation for this model, and neither the columns have any description. It is referenced by FCT fact sales. It lists all the models that is referencing this model, which includes fact sales. Fact sales actually referencing this model, so it lists that, and this depends on one thing, which is STG orders, stage orders. It depends on stage orders, and also it also lists the macros that this particular model is depend on, which is add margin, because this model has this macros referenced, so it is also dependent on this margin. Without this macro file existing, this model will fail. So it shows all the dependencies here. Oh, and by the way, the code, it shows the code that we wrote and the compiled version 2 at the same time. Now I think you know how the documentation works, and it is so important as well. All right, and here, by the way, here you can actually see the lineage graph, which is cool, right? In an interactive way. The lineage graph, this is the basic lineage graph that we created, which is so simple. Stage orders, and that flows to int orders matrices, and that flows to fact sales. When we view full screen, so this is how it goes. Okay, so that is the lineage graph. And it is interactive, like I said. Oh, we can actually select what we want to see and what we don't want to see as well here. From here, there are tags, but that's fine. This is enough for now. So let me close that. So we're done with this module as well. Documentation. This is also an important module we have to know about. So we're done with that. And our next module is module 12, lineage and impact analysis. This module is so short. This is nothing but an extension of knowing about lineage, the dependency between the models that we create, and the safety precautions we have to take before we actually manipulate anything. Okay. And to be clear that if we modify any model, the downstream will be affected accordingly. So something, the stuff like that is included in this one, maybe even in deeper and even in more clear way. If you haven't got a clear idea about the lineage yet, this module will help you a lot. If you're wondering still what lineage is about, lineage is nothing but a dependency graph, a dependency DAG graph. That's it. It's just still a DAG graph, but it only shows the dependency and nothing else. Just like this one right here. Yeah, I don't have to show that. I can just show you this one, the UI that we just saw. This is the lineage graph. Like it says right here, lineage graph. Whereas DAG has a lot of other stuff, but lineage only shows the dependencies graph. And it shows how it goes and the basic conceptual flow. I'm going to just give you a brief of what this module is because we already talked a lot, even more than enough stuff that is in this module already. So I'm going to just give you a brief of what this module is about. So it starts with a conceptual diagram. It says source layer, where we get the source data from using source of, right? Source of. So it includes something like raw.orders, raw.customers, and then comes staging layer where we actually store the data that we get from the source using source of. Something it has some the model is something like stage underscore orders, stage underscore customers. And there is transform layer, which is the intermediate layer, which has intermediate matrices or fact orders or something like that. And then comes mart layer, which is the business ready data storage, basically. And each arrow dependency created by either reference of or source of. If the data or the model is inside the DBT or the project, we use ref of, like we know, and we use source of if we are referring to an external table. Okay, that is clear. We all know how sources, how we define source, right? We use the expression block and then we say source of and the table and and the schema and the table from that schema. We use this already, so we already know how it works. And we use ref of in this way, same with the expression block, and refer to the model that we are referring to. And there are two ways to think about these lineage. There is upstream and there is downstream. If you want to see if you want to see what this model is dependent on, we see the upstream. So if you want to see what, no, wait. No, sorry. So this is upstream. Upstream equals inputs. So it shows the upstream graph where the mart revenue is at the top and row orders is at the bottom. So the flow, the stream flows upwards. And then there is downstream, which is impact surface, which is nothing but the same as upstream, but a reciprocal of it, just an opposite of it, where the mart revenue is at the bottom and the stage orders is at the top, and the stream flows downwards. Impact analysis. So you have to be clear. This is just about knowing to deal with these lineage when you change anything, any model in between. So if you change any model after you constructing after you constructed a lineage graph, you have to be cautious to know what changes if you modify that particular model. So you have to see what breaks. So this should be the question. If I change this model, what breaks? Example, if I change stgorders.sql, what changes? Everything downstream changes, right? Everything downstream gets impacted. So the downstream includes fact orders, mart revenue, and everything. All the stuff is impacted. That is how you have to think. And now we talk about the safe changes and unsafe changes. The safe changes includes adding a column to the model. That doesn't change anything. That doesn't impact anything downstream. So that is fine. That is a safe change. Nothing breaks. So that is a safe change. Now, a breaking change example includes removing a column. Now, when you remove a column, if any of the downstream models reference to that column and depended on that column, that will break the graph, the flow, the stream, and that is not safe, right? Because that will break the flow. So you have to be careful when you modify a model. Well, adding a column doesn't do anything, so you can just go for it, but removing a column will. So you have to be careful when you remove a column or something like that. And we talk about selective execution using lineage. We already talked about this already, right? We talked about it when we talked about CI strategies, right? So we use this. So we're not going to talk about that. That is fine, and that is fine. We also talked about viewing lineage in docs by creating the docs, by generating the docs and then serving it in a web page with a UI like this. We already talked about it, so we don't have to talk about it again. Okay, now we talk about real production debug scenarios. Let's assume the CEO of the company that you work says revenue dashboard looks wrong, and this is the flow that you have here. What you have to do, so if the dashboard look wrong, you have to go searching to the upstream, right? So you have to trace back the stream, because the dashboard is dependent on the mart revenue, and the mart revenue is dependent on the fact orders, and fact orders depend on stage orders, and it is dependent on raw.orders. That is the base of that. So you have to trace through the stream to actually debug that, or find what is making that dashboard get that error. Yeah, that is basically it about the lineage. Now let's let's head to the next module, which is module 13. And for the next module, we have module 13, incremental optimization and performance strategy, which belongs to phase 5, performance engineering. This talks about the best practices and best practices in optimizing the incremental and performance strategies. So this doesn't have any lab. I'm just going to go briefly of what to do, just like the last module. Okay, so what this module does. This is where dbt stops being just SQL and becomes an execution engine. Two pillars: how dbt compiles and executes models internally, how incremental strategies scale production pipelines safely. These are the two pillars that we are going to focus in this module. In the part 1, query compilation and execution flow. When we run dbt run, dbt does not execute SQL files directly. What it does is it goes through a deterministic multi-stage lifecycle like this. So these are the project files that we define, right? And then project parsing. So the project gets parsed. And the DAG is constructed through the project. Jinja is compiled. All these are compiled and made into an executable SQL file. And then SQL compilation happens. Pure SQL is generated, like I said, and execution planning. Database execution. So execution planning is done first. The planning is done first, and then the execution is happened in the database. After that execution, the materialization happens. Depends on how the materialization depends on how we define the materialization. Those outputs of the models that are executed in the warehouse will get those materializations. If it is a table, it creates a table. If it is a view, it creates a view. It depends. And then the metadata recording, which includes manifest.json, which saves the logical plan, the DAG, and run results.json. Now, dbt is a compiler, a dependency engine, an execution planner, and a metadata recorder. But dbt itself is not an executor like we talked before. It doesn't execute anything. It just compiles and connects acts as a dependency engine and also execution planner. It plans the execution. It won't execute, but plans the execution, and it records the metadata of those executions. Stage 1, project parsing. dbt scans all the folders. It registers model sources, tests, macros, and configurations. And stage 2, DAG construction. When dbt sees something like this, it creates a dependency edge, because this particular model is referring to this model, which creates a dependency. So the DAG is constructed according to those dependencies, and it creates a dependency edge, something like this, right? And then this graph is stored in manifest.json, because that is the place where the DAG is stored. We know about it already. I talked about it already, right? And after that, the Jinja compilation happens, where all this Jinja template will be converted into an executable SQL, something like this. Okay, we talked about it. And then materialization wrapping. And after that, your model SQL is wrapped based on materialization. Example model. If the configuration is says the materialization as table, the compiled materialization will be create a table and then create the particular table with the definition that we defined. Execution engine. dbt connects via profiles.yml. It depends on the profile that we define in the profiles.yml file. It connects to that particular warehouse that we define in that profile. Metadata recording. Manifest.json project structure. Manifest.json saves the project structure, the DAG, and compiled SQL as well. Whereas runResult.json saves execution order, status, and runtime. Part 2, incremental model strategies and trade-offs, which we already talked about before when we talked about the incremental table model. That's the same thing. Instead of building the whole table again, it just increments with the new rows that are ingested. That's it. That is the whole concept of this as well. We already talked about it, so we are not going to talk about it again. So it is basically nothing but diving deep into that incremental model concept. That's it. Nothing new. And here are the trade-offs between table and incremental table. Table is simple, incremental is complex. We have to know a lot of stuff. You have to be clear about incremental table behavior to actually use it, or else there is a big risk you misconfigure it and lose or corrupt your data. Table is reliable, incremental is risky if misconfigured. You have to be so clear of what you're actually doing to actually implement that model or implement that table model. Slow for big data, extremely fast for big data. No matter how big the data is, this is relatively faster than a normal table. Low operational risk, requires discipline. So those are the trade-offs between table and incremental table. With that, we're done with this module as well. Let's head to the next module. I know this module is quite smaller. I mean, the upcoming modules are also smaller because they're mostly theoretical and not much of a practical stuff is included in these things, because that doesn't make any sense to actually make these practical, because we already had a lot of practical stuff done already. So we're just going to go with the theoretical one now. And for our next module, we have PostgreSQL optimization for dbt. Well, here in this case, we used PostgreSQL. So I named this module as PostgreSQL optimization. But if you use any other database, you have to you have to follow the same rules no matter what database you use. Okay. So like I said, this also has only the theoretical part to discuss about, because the practical part we already done a lot of stuff, even better stuff that we can possibly do already, so we don't have to do that again. Starting with the module, we start with PostgreSQL decides how fast it runs. If you ignore database internals, performance collapse at scale. So we have to be careful of what we execute in our database so we don't ruin the performance. So we don't need to use more computation or make the database work harder than we actually need to. So we see in this module, we see a few ways to actually execute a command or dbt run. So it reduces the load that is put on the database by using selection patterns. Let's say we have this conceptual tag. Okay, let's say we have this, which has raw orders, and we have stage orders, and we have fact orders when we have mart revenue. This is just an example. We don't have that. We have a different model, but for example, let's say we have this conceptual tag with these models. Okay, and talking about the core selection patterns, there are a few models to select. There are a few patterns to select what we have to run. First one is single model, where we only select one particular model if we want to run only one node. We say dbt run, select fact orders. That's it. It only runs one model, which is fact underscore orders, and nothing else. But there is a risk comes with this, and the risk is upstream dependencies are not rebuilt. If you only run fact orders, fact underscore orders, only that will be executed, and the upstream which the fact orders depends on will not be executed, and that can break the stream. So you have to be careful with that. And by the way, what I just did is, because we are hosting a website locally with this command prompt is dedicated to that. So what I did is I just closed the hosting now, which means we cannot actually access this. If you refresh, that is gone. So I just closed it using Control plus C to exit, like it says here, use Control plus C to exit. So I exited that, and I ran a command where it only runs fact orders and nothing else. When I ran that, it says the selection criterion factors does not match any enabled nodes. Nothing to do. Try checking your model configs and model specs args. Oh, it cannot. Oh, sorry. Uh, so it is not fact orders. We have something called fact sales, not fact orders. Okay. Now this should work. Let me run that. Now this will only execute fact underscore sales. That is fine. But if you also modified something upstream to that, that changes will not be executed if you only run fact. If you only run this one, the upstream tables will not be updated because those are not compiled or executed. Only fact orders is executed. So you might get the output which is older than you need. So you have to be careful when you run selective model or the single model. And the next pattern is include parents upstream, where we already know when we run something, we select and we also execute the upstream that is related to this particular model. So it also runs the upstream. And this doesn't have any risk because it is safe. Dependencies are rebuilt. So the dependencies, the upstream or rebuilt. So this is safe. So the data is updated. Everything is updated. So this is actually safe, but this is not. You have to be careful when you run it. You have to be careful. If you do any changes to the upstream, you have to be careful when you run it. You have to instead go with this model in that case. And include children downstream, which basically runs all the downstream models when we run this command. We know most of this part, right? And we also know full dependency chain, but this is also part of a pattern model where we actually include the full dependency chain, only the models that are connected to this stream alone will execute and nothing else. And then we have folder based selection. Instead of selecting one particular model or downstream or upstream of the model, we can actually select the entire folder and run something on it, run an action on it. So we can say dbt run and select and say staging. So it runs the whole folder. Okay, so when we run this, do that. Oh, this typed in, okay, that's perfect. When we run this, only the models that are inside the staging folder will execute, which are three: STG orders, STG seed test, STG customers, or the three models that are in the staging. There is folder based selection and there is tag based selection. We haven't talked about it yet. We never did that before, but we can actually use this part in our model at the top where we configure stuff, and we can tag that model using this one. Okay. So no, it's not worth it. So we can actually do that. You know what? Let me just copy paste it somewhere to demonstrate it. Let's say I am going to configure that for this. Okay. Tags. Now I'm sticking a tag to this model, and the tag has only one tag, that is finance. We can also add multiple tags to one model, that is still fine. And when we say dbt run select tag finance, every model that has that particular tag will execute. That's it. That is how it works. This is what tag based selection is about. Okay, let me run that now. And there you go. Only that model with the matching tag gets executed. Tag based selection. Now execution pattern. dbt run select marts exclude mart revenue. This is an execution pattern, basically like a conditional logic. We say dbt run select the whole folder, which is marts, but exclude mart underscore revenue from that folder. So it excludes mart underscore revenue from that folder and execute every other model in that folder. Well, we can say fine-grained execution control. We have more control of what we execute. This is one way to execute. And then state-based selection. We talked about it when we talked about CI, right? Continuous integration, where we save the manifest.json in a separate folder, the old state, and then we use modified plus and then hyphen state. We connect to the old state and run it the same way. And the lab has everything that we just talked about and demonstrated about. So I'm not going to demonstrate again, which doesn't make any sense, right? We just move on, and that's it. We are done with this module as well, module 14. Next, let's head to the next module, which is module 15, phase 6. And the next module is module 15, development versus production architecture, which belongs to the phase 6, environment plus production strategy. In this as well, we only talk about the logical part and the theoretical part. We're not going to execute anything because we already done a lot. Beginning with this, if environments are not separated, you don't have environments, you have chaos. So the environments has to be separated, the development environment and the production environment, and yeah, that's it. This module defines how to separate dev and production safely and prevent cross-environment contamination and ingest configuration dynamically, handle secrets securely, control execution safely. First, we begin with the conceptual architecture, which includes dbt code. Okay, and then we separate them into two different environments, development and production, which we already did at the schema level separation, right? And here we say the target.name equals dev, target.name as prod, which is production and development, and we have schema, separate schemas for both of them. So same code base, different runtime resolution. Hard separation is mandatory between both the environments. And now we talk about target separation. What is a target? We define target in profiles.yml. We already did at the beginning of the masterclass, where we separate the target. Where we separate the profiles for development and production separately. And how to switch a target? We can switch a target when we write a command. We already did it. When we write, let's say dbt run, we can just say hyphen target and say prod pure OD. So it switches the target to that profile, prod, and runs it out in that way. We know how to switch that, so we don't have to talk about it. But here's one new thing that we have to talk about, which is here we just did a schema level separation for production and development, right? But when I said in real world, when you work on a real production grade project, you actually do database level separation for development and production, right? We talked about it, but just a separate schema for production or separate schema for development is not enough. We also need a separate schema for CI, continuous integration, because when you, as a developer, let's say you do a pull request and it gets approved, the CI is get triggered. The CI get triggered, right? And as part of the CI continuous integration process, it goes through a few tests: dbt freshness test and dbt run, dbt test, right? And when it executes dbt run, you don't want that to execute in development schema or production schema. So what you do is you also create a separate schema for CI alone. So these commands that we run as part of the CI can be run on that schema and not contaminate any of these other environments or other schemas. So in real production, we also create a separate schema for CI as well. So the dev underscore schema is for developer writes here, and CI schema, CI builds here. Production schema is for production only. Each environment is isolated, no overlap. We talked about it. Okay, we are not going to do any of this lab because we already done how we switch the target, so we don't have to do that. We talk about model selection strategy across environments. We also talked about this as well, right? When in development environment, when developer modifies fact orders.sql, in development environment, we can only just run dbt run and select the upstream and downstream, both the streams of that particular model. That's fine. But whereas in CI pattern, we can use this to see what is modified and run that part alone by using this command modified plus. But whereas in production pattern, we already talked about it. We run entirely. We run the entire DAG. We are not going to select only the modified part. We run entirely. That is how production pattern should go. And we talked about it. And we now head to environment specific variables. Here we talk about environment specific variables, where we use variables to basically access the reusability. We already used variables once in before the previous labs, right? We use variables for the reusability of a particular integer or something like that. And there is also something called environment variables. We use environment variables in a situation where we want to hide the credentials or any secrets that we don't want to expose in our code. We can use environment variables there. So we define the password or username or some sort of secret at environment level, and we can use the variable instead of hard coding the actual secret in it. That's how the environment variables work. So it has something like this. So we use this type of variables already. They are regular variables. We use them already. So that's fine. But these are environment variables. So if you installed dbt core on your machine directly without using Docker, you can just use this command to actually define an environment variable. If it is a Mac or Linux OS, this will work. But if you're working on a PowerShell, the command is quite different to create an environment variable. So whatever, if I run a command here to define an environment variable, so whatever command, whatever code that I execute here can have access to that environment variable because that variable is defined at environment level. So everything has access to that. That is how environment variables work, but I don't want to demonstrate it because it is so simple, but we just want to know theoretical part of it. We don't have to demonstrate it. So that's fine. Because we already demonstrated how we can actually use regular variables, so we don't go too deep into it. Secrets handling, the same thing. And yes, with that, we're done with this module as well. Let's head to the next one. Now for our next module, we have module 16, packaging and modularity. This is one of the important module we have to know about. We have to learn about. And this does have a demonstration. This one actually have two labs, but I'm just going to do one lab because the second lab is kind of hard. It takes too long time. It is not hard, it is so easy, but it takes too long to actually prepare everything to demonstrate one thing, just to prove one small point. So it is not worth to prepare everything. It takes a lot of time. Okay. So this module defines how you scale beyond a single project. If you don't modularize, your dbt code database eventually becomes a monolith. This is the conceptual diagram. Here we are going to talk about dbt packages, dbt utils, and internal packages. Packages extend our project without duplicating code. They can provide macros, models, tests, utilities, shared standards. Now, part one is installing external packages. Now we are going to talk about external packages. Before that, we have to talk about what a package is. A package is a reusable dbt project that can be installed into another dbt project. Example, for an external package, we can use dbt labs. So dbt labs maintains the widely used dbt utils package. So it has the widely used. It is widely used. The dbt utils package is widely used. So it provides dbt labs provides dbt utils package, and that package provides reusable macros and tests that are already predefined that we can use by importing that packages into our project and use those predefined packages or predefined macros or tests in our project. Step 1, this is how it should go. Step 1, define the package.yml, package route and package.yml, package install dependencies using dbt deps, and it downloads all the packages and we use it. That's it. Now I'm going to demonstrate how we actually use those packages by importing them. I mean the external packages. And this is the lab. First, we're going to create packages.yml file. So let's do that. Under dbt project, right here we create a file named packages.yml. All right. Let me close this. Create a new file. packages.yml. Oh, it already exists. All right. So packages. Oh, I just created it. Okay. Now paste this. We're basically defining the source dbt labs and connecting to the package dbt utils. This is a public something like a community source where we get the package from. Okay, let's copy and paste this here under packages.yml and save it. Now we install those packages using this command, docker compose run and dbt deps. This is the main part of the command, dbt deps. So it installs all the dependencies. So when we run it, when we run the command, it installs all the dependencies. So running with dbt, updating log file in the file path, user package log.yml, installing dbt labs, dbt util. So it installs everything. Now it is installed. It confirms the installation using saying installed, updated version available. Oh, whatever, that's fine. So we predefined the version for that package as 1.1.1, but it says there is an updated version which is 1.3.3, but that's fine. This is how we actually install a package. Now we installed it. After that, the next step is to verify this directory now exists, which is dbt project, dbt packages, dbt utils. There you go, dbt packages, and let me extend this. So dbt packages, dbt utils, everything gets imported into our project repository. Now we can use anything. We can use everything that is available in this folder now for our project. That is how it works. It has a lot of stuff. We can select one from that and run it. Okay, we have that. Now we're going to use a macro from that dbt utils that we just imported, where we're going to create a surrogate key. So what we're going to do is we're going to create a new model named test surrogate.sql. Under models, I'm going to create a new model, test surrogate.sql, and in that I'm going to write this SQL query, which is nothing but selecting order ID and just assigning one as a customer ID because we don't have any customer ID column, and we are referencing from staging model, which is stg orders. And then for the third column, we have dbt utils.generate surrogate key. So we're going to generate surrogate key uniquely for every combination of order ID and customer ID. That is how surrogate key goes. A surrogate key is nothing but a unique key for a combination of two or more values. Okay, so if that particular column, let's say, to define a surrogate key, here let's take this example. Okay, we have what? Order ID, and we also have customer ID, right? Now let's say we have a combination order ID as 1 and customer ID as 2, and also a combination of order ID as 2 and the customer ID as 4, and another row with the combination of 1 and customer as 2 again. Now what happens is when we assign a surrogate key, when we assign a separate column, say SURR, which represents the surrogate key, what happens is, because we define the surrogate key as these with these two keys, right, with these two columns to create a surrogate key, what happens is it creates a unique key for every combination of these two columns. So just for example, for these two, for the combination of these two, 1 and 2, it creates a unique surrogate key. That's fine. And let's say the surrogate key is something like this. Just for an example, but the surrogate key looks nothing like this, okay? Just for an example, this is a surrogate key created uniquely for this combination, all right? And the same thing happens for this. So it creates another unique surrogate key for these two combination, this combination of these two values. And let's say that surrogate key is something like 5678 or something like that. Now, when coming to this combination again, what the surrogate key does is, it, like I said, it is only unique for a particular combination. That's it. So what this does is, this combination is already exist, right, at the top. So it assigns the same surrogate key for this one as well, which is 1, 2, 3, 4. And that is how surrogate key works. It only creates a unique key for a combination of keys, a combination of values. Okay, I think you got the idea now. That is how surrogate key works. So we use that package, we use that macro, basically, we use that macro from dbtutils package that we just imported. We haven't wrote any logic, right, for this macro. We haven't defined this macro, but we just got that from an external source, which is a community type thing. From dbt lab, we installed this dbtutils package and we wrote that and got that. I mean, we haven't got that, we just wrote this. Now, sorry. Now, when we run dbt run, when we do dbt run, okay. Instead of running the whole thing, I'm going to select that particular model alone. Okay. Say, select what? Test surrogate. Perfect. I'm just going to run that model alone. Run it. Will it got an error? It says what? Oh, I know why. I know why. That is because we just created this column in this query itself, in this transaction itself. But that is not how SQL works. If we create something in that transaction, it cannot be used in the same transaction. So it technically this is not created yet. This only gets created once this whole transaction is completed. So we cannot actually use customer ID in this. What we can use instead is, you can use something else from STG orders. And what we have here, we have order ID and amount, right? So let's use that instead. Okay. We use amount instead of customer ID. Amount, and do the same here as well. Amount. So that should fix the error. Now let's run that again. No. This runs everything. Yeah. I just want to run this selectively, that model alone. to see actually if it is working or not. There you go. Now it is working. It creates a surrogate key, a unique key for the combination of those keys. Now, for the final touch, because we're not going to do any other practical stuff after this, because we are almost done with the masterclass, I'm also going to connect to Warehouse and see if those surrogates key are executed in the right way and the packages are working. To see that, we run select all from this thing that we just created, close the transaction. There you go. We created we assigned a surrogate key for every unique combination of order ID and amount. And there it is. So that is good. That is how it works. Okay, we're done with that lab. Now we talk about internal packages. Instead of we downloading external packages from an external source, we can actually use a package or a project that we create inside a project that we create. Okay, so it is like we can use a package, we can use the stuff inside a project that we created in a project that we created as well. So if we have two projects that we created, we can use stuff that is in one project in another project as well. That is what internal package means. Okay, so to make the example clear, okay, here in this project we define a macro as matrix.sql, this one. So if you have another project we create in a different location, we can still use this macro in that project as well by connecting something like this, installing that project into our existing project that where we want to use that macro at. Let me show you an example. Oh, we came to the lab here. Okay, here it says create a package directory. So it says to create an actual project separate to the project that already exists, but I'm not going to do that because, like I said, it is too much of work to prove a small point. Well, it is not worth it. So we create the whole project, right, with the dbt project .yml and everything's all the stuff. We create the project and we do everything. And then we create a macro. We will have a macro in that. And then what else? Okay. Now in the main project that we want to use that the other project's material at. So in that main projects, we have to create a folder. We have to create a file name project packages.yml, just like we did before, which is this one. So instead of referring to an external package, what we are going to do is we're going to do local and refer or navigate to the folder where the project is, the main project repository is saved at. So we just navigate through that and then define it here. That's it. It is that simple. And then we run the same command we run before when we install the external package, which is dbt deps. This will install everything that we need, all the dependencies that we need to run the packages that is inside those packages.yml. And just like that, we can now access the macros that are defined in that secondary project in our main project that we created. That is how it works. It's quite simple to installing an external package. It is even simpler than that, basically, because you create the macro and you use it in a different project. So that is a lot simpler than relying on a public source, basically. That is it. That is it with the module 16. I think we're done with that. With that, we are officially done with our masterclass, with our DBT masterclass. Hope you got some knowledge and everything that we used. This document, this masterclass document will be given to you, and also the Docker Compose file and the Docker file, which I said I'm going to give you at the beginning, will be given to you in the GitHub repository link. And this file, this Word document, I'll try to give it to you as a link, so you can just watch that document online, or I will also try to give it to you as a whole Word document. Whichever is fine. You can pick one and get this document handy. And with that being said, I'll be back with another video, maybe within a week. Maybe I'm going to I'll be back with a project, with a DBT project, just a follow-up for this masterclass, and meet you guys again. Adios.